Hi guys, in a previous video we had a little bit of a course overview, we had a little look into what sort of content we're going to have, and we also learned a little bit about me and what I do. So in this video we're going to be taking the first steps into getting started, basically preparing the sort of lab so that we can start working in penetrating science and various tools that are available to us. And as the title of the course may suggest, we'll be using an operating system called Kali Linux. And we're going to be finding and downloading that first, of course. Potentially we can make it as a host operating system, but a lot of people prefer to just make it in a virtual machine. So I've decided to show that in this video as well. And of course we'll be also installing Kali Linux and then looking forward to moving on and starting working on the tools that are available to us within the operating system. So first we're going to go to kali.org and we are going to want to go to download, and here you can see we've got various images available to us. We can download these from an ISO or a torrent depending on what you want to do, and we also have VMware and VirtualBox images available to us. So I would choose the 64-bit because I have a 64-bit computer. Now I could potentially use a VMware image, but it comes out with some default options, and I want to go straight from a 64-bit Kali Linux image. So I've decided to just show that really. So there are many options, but today I'm going to be using this 64-bit option. If you don't obviously have a 64-bit computer, then you can use the 32-bit. So I'm going to start creating a virtual machine to put the operating system Kali Linux in, and of course first of all what we need to do in VMware is, and also VirtualBox, is begin creating a new virtual machine. The process is relatively similar, but one thing to note is that I do know that there is something about physical address execution within VirtualBox that you may need to look at if you are using VirtualBox. So we're going to be using a very typical recommended installation. We don't need to use custom. We're going to say I will install the operating system later. We don't need to go through this right now. And we're going to choose the Linux, and I am going to choose just other 2.6 kernel 64-bit. I'm going to call this Kali Course Machine so that we can identify the machine, and then you can specify what hard disk space you want. I'm going to give it 20. And I'm going to leave this as split virtual disk into multiple files, and then next. And then I'm going to customize the hardware a bit. I don't want to have it as 384 megabytes. It's a relatively similar process with VirtualBox. I'm going to give it around a gig. And the CD DVD, now we can specify the ISO image that we're going to be using. So we need to find that. So I've got the Kali Linux 1.09 AMD64, and I'm going to be installing that using the ISO image. And what we need to do now is we just need to start the virtual machine, and it will automatically detect the CD DVD, the virtual one, because we've shown the location of the ISO image. Right now I would just close that. We don't need to look at that, and straight away we can see that we have the boot menu for Kali Linux. What we're going to be choosing is we're going to be choosing the install option. We don't want to choose all the others because they are live. We want to keep it on this machine and install it. And this is going to be a pretty typical Debian installation. Kali is built on Debian. What I've done there is I've simply pressed enter on the language that I want. You can also navigate around with the arrow keys up and down, and I'm going to press enter again because I live in the United Kingdom, and also that I'm British, and it'll detect hardware and do just a typical, like I said, Debian installation. If you're aware of Linux or you've done a Linux installation, then you probably can skip this part of the video. If you're a Windows user, you may be a little bit alienated by this installation right now, so you can follow with me. But it's a relatively simple process. It sets everything really up for you easily, only really specifies certain things that it needs. So I'm just going to let this run. Oh, there we go. So the host name, I don't really need to change anything. I haven't got anything that I want to call it in the network, so I'm perfectly fine in a virtual machine and calling it Kali. You can call it whatever you want, that's up to you. Same with this, domain name, no need for a network, so I'm just going to continue. The root password is relatively important, so you should enter it. And then you need to re-enter that. And what I've done there is I've entered it, and then I've pressed the down key, which goes to continue, and then I'm pressing enter. So I don't need to encrypt anything. I'm just going to use guided, use entire disk. If you want to go into encrypted, you can. I do advise not to use manual though. We've only got one partition. I'm going to put all files in one partition because it's a virtual machine. If this comes up in VMware Tools, you can Control Alt to get out of the virtual machine. And we would just want to say remind me later right now because we're too busy with the installation. And then we have once we've selected the partition, we can say finish partitioning and write changes to disk. And this is the option where you don't want to say no, you want to use the left key and choose write changes to disk, yes, and click enter. So now that that's installing the system, this is the time where we can have some cup of teas, really. We can have a cup of tea and wait for it to finish to the next step. Obviously, you have to keep checking to make sure so you don't waste a lot of time, but this is the point where you can just relax for a moment and wait for it to finish. So you will get this pop-up now saying a network mirror can be used. I choose yes. I quite like the idea of using a network mirror. I don't need to use a HTTP proxy, so I'm going to leave that blank. And then it's going to configure the apt. Now, we do want to install the grub bootloader. So we choose the yes option, the default option, we just simply press yes. And this will basically allow it to boot straight away from the master boot record in Kali Virtual Machine. So after all of that, you'll get this message saying that the installation is complete. And that's great, that means that Kali is installed. So if we choose the continue option by pressing enter, it will start finishing up the installation and it will reboot and we'll be able to log in to Kali Linux. So it's now restarting the system. We see the VMware, the grub bootloader. We can just leave this to run because it will automatically choose that one in a few seconds and we will be presented with the login screen very soon. And there we have it. We have the Kali Linux login. And we are able to log into the system. We have successfully installed Kali Linux and created a virtual machine. So to summarize, we've found different options to download Kali. We could have got some VirtualBox/VMware images that were pre-done for us and we just simply had to run them from our virtual machine clients. Or we could have done what we've just done, installed it from an image ISO. As well as that, there's also support for Raspberry Pi and other hardware for Kali Linux. So we've also created the virtual machine, as I've said, and we've created some specific hardware specifications. I've changed the hard disk as well as the RAM to make it quite good at running certain programs. I do advise to run it at 1 GB. I think that's a sufficient amount. And I've walked through the installations and we've successfully installed Kali Linux. We've got to the login screen. Now we can look into Kali Linux and the interesting stuff that it has within it. So in the next video, we're going to be looking inside of Kali. We're going to be using Kali and sort of getting to grips with the certain basics of Kali Linux. Hi guys, welcome to the video course Kali Linux Web App Testing. This is brought to you by Pact Publishing and my name is Jack, but you can also call me Link Cabin. So first of all, we're going to be looking at a course overview. We're in section 1, the first video, and we're just going to be looking inside the different sections and what is included within these sections. But first, a little bit about me and what I do. I'm an independent security researcher. I'm really passionate about sort of putting the idea across that information security is a really interesting subject and is a really important subject. I've been part of several bug bounties and I've found vulnerabilities in various places of the internet. The goal of this course is to help develop knowledge in a growing sector. So information security in a whole, web penetration testing, it's getting bigger. There's much more need for it than ever before, and it's going to grow even more as more and more applications are created within the internet. So it's becoming a growing sector, certainly. I want in this course for people to have a solid understanding of Kali Linux. We're going to be mostly looking at web penetration applications that Kali Linux packages, but the parts of the first section also include some basics with Linux. So I want people to have a solid understanding, and I hope that this course does provide that. Also, within every single section, except the first section, there is some concepts on common flaws in web applications, and hopefully by the end you'll have some ideas of different common flaws within web applications. So we'll be using a sample script within this application. Every section will use it, and it's just basically a script I've designed so that people can test different vulnerabilities, and it has every vulnerability that is within this course that is provided. So it's very easy to use, open source. You don't have to go on any other website. It's made with PHP, HTML and CSS as well as MySQL. So within section 1, we're just starting off. We'll be looking at some basic Kali commands, simple Linux commands, and we'll be taking the first steps. So we'll be installing Kali and looking at it in an overall operating system sense. In section 2, we'll be looking at injection, XSS injection and SQL injection, using the applications to identify these as well as the defense on these two. And then in section 3, we'll be looking at local and remote file inclusion. Again, the application to use within Kali Linux to identify these, as well as directory traversal, which is in tandem with them too. Then we'll be moving on to avoiding forced attacks, section 4, where we'll be looking at hash brute forcing and form brute forcing, the brute forcing concept, and the applications that we'll be using to use brute forcing on the average shop script to sort of get the concept of hash and form brute forcing across. So in section 5, we'll be looking at a whole array of different vulnerabilities, as well as a sort of introduction to vulnerability scanners, which is quite pinnacle to web penetration testing. In section 6, a little bit about what CSRF is, Cross-Site Request Forgery. We'll look at testing tools to replicate that, and also the defenses against CSRF. So in section 7, we're rounding off, and there's another vulnerability scanner that I talk about, as well as some other vulnerabilities, as well as the ending 7.5 wrapping up. Some notes before we delve into the course. In order to follow along, you need to be a developer familiar with creating web applications. Some basic knowledge in Kali Linux would be great, but is not necessary, as we will cover everything in the course. In the next video, we'll be looking at taking our first steps. Hi guys, in a previous video we had a little bit of a course overview. We had a little look into what sort of content we're going to have, and we also learned a little bit about me and what I do. So in this video we're going to be taking the first steps into getting started, basically preparing a sort of lab so that we can start working in penetrating science and various tools that are available to us. And as the title of the course may suggest, we'll be using an operating system called Kali Linux. And we're going to be finding and downloading that first, of course. Potentially we can make it as a host operating system, but a lot of people prefer to just make it in a virtual machine. So I've decided to show that in this video as well. And of course we'll be also installing Kali Linux, and then looking forward to moving on and starting working on the tools that are available to us within the operating system. So first we're going to go to kali.org, and we are going to want to go to download, and here you can see we've got various images available to us. We can download these from an ISO or a torrent depending on what you want to do, and we also have VMware and VirtualBox images available to us. So I would choose the 64-bit because I have a 64-bit computer. Now I could potentially use a VMware image, but it comes out with some default options, and I want to go straight from a 64-bit Kali Linux image. So I've decided to just show that really. So there are many options, but today I'm going to be using this 64-bit option. If you don't obviously have a 64-bit computer, then you can use the 32-bit. So I'm going to start creating a virtual machine to put the operating system Kali Linux in. And of course, first of all, what we need to do in VMware is, and also VirtualBox, is begin creating a new virtual machine. The process is relatively similar, but one thing to note is that I do know that there is something about physical address execution within VirtualBox that you may need to look at if you are using VirtualBox. So we're going to be using a very typical recommended installation. We don't need to use custom. We're going to say I will install the operating system later. We don't need to go through this right now. And we're going to choose the Linux, and I am going to choose just other 2.6 kernel 64-bit. I'm going to call this Kali Horse Machine so that we can identify the machine, and then you can specify what hard disk space you want. I'm going to give it 20. And I'm going to leave this as split virtual disk into multiple files, and then next. And then I'm going to customize the hardware a bit. I don't want to have it as 384 megabytes. It's a relatively similar process with VirtualBox. I'm going to give it around a gig. And the CD DVD, now we can specify the ISO image that we're going to be using. So we need to find that. So I've got the Kali Linux 1.09 AMD 64, and I'm going to be installing that using the ISO image. And what we need to do now is we just need to start the virtual machine, and it will automatically detect the CD DVD, the virtual one, because we've shown the location of the ISO image. Right now I would just close that. We don't need to look at that, and straight away we can see that we have the boot menu for Kali Linux. What we're going to be choosing is we're going to be choosing the install option. We don't want to choose all the others because they are live. We want to keep it on this machine and install it. And this is going to be a pretty typical Debian installation. Kali is built on Debian. What I've done there is I've simply pressed enter on the language that I want. You can also navigate around with the arrow keys up and down, and I'm going to press enter again because I live in the United Kingdom, and also that I'm British. And it'll detect hardware and do just a typical, like I said, Debian installation. If you're aware of Linux or you've done a Linux installation, then you probably can skip this part of the video. If you're a Windows user, you may be a little bit alienated by this installation right now, so you can follow with me. But it's a relatively simple process. It sets everything really up for you easily, only really specifies certain things that it needs. So I'm just going to let this run. Oh, there we go. So the host name, I don't really need to change anything. I haven't got anything that I want to call it in the network, so I'm perfectly fine in a virtual machine and calling it Kali. You can call it whatever you want, that's up to you. Same with this, domain name, no need for a network, so I'm just going to continue. The root password is relatively important, so you should enter it. And then you need to re-enter that. And what I've done there is I've entered it, and then I've pressed the down key, which goes to continue, and then I'm pressing enter. So I don't need to encrypt anything. I'm just going to use guided use entire disk. If you want to go into encrypted, you can. I do advise not to use manual though. We've only got one partition. I'm going to put all files in one partition because it's a virtual machine. If this comes up in VMware Tools, you can Control Alt to get out of the virtual machine, and we would just want to say remind me later right now because we're too busy with the installation. And then we have once we've selected the partition, we can say finish partitioning and write changes to disk. And this is the option where you don't want to say no, you want to use the left key and choose write changes to disk, yes, and click enter. So now that that's installing the system, this is the time where we can have some cup of teas, really. We can have a cup of tea and wait for it to finish to the next step. Obviously you have to keep checking to make sure so you don't waste a lot of time, but this is the point where you can just relax for a moment and wait for it to finish. So you will get this pop-up now saying a network mirror can be used. I choose yes. I quite like the idea of using a network mirror. I don't need to use a HTTP proxy, so I'm going to leave that blank. And then it's going to configure the apt. Now we do want to install the grub bootloader. So we choose the yes option, the default option, we just simply press yes. And this will basically allow it to boot straight away from the master boot record in Kali Virtual Machine. So after all of that, you'll get this message saying that the installation is complete, and that's great. That means that Kali is installed. So if we choose the continue option by pressing enter, it will start finishing up the installation and it will reboot, and we'll be able to log in to Kali Linux. So it's now restarting the system. We see the VMware, the grub bootloader. We can just leave this to run because it will automatically choose that one in a few seconds, and we will be presented with the login screen very soon. And there we have it. We have the Kali Linux login, and we are able to log into the system. We have successfully installed Kali Linux and created a virtual machine. So to summarize, we've found different options to download Kali. We could have got some VirtualBox/VMware images that were pre-done for us, and we just simply had to run them from our virtual machine clients. Or we could have done what we've just done, installed it from an image ISO. As well as that, there's also support for Raspberry Pi and other hardware for Kali Linux. So we've also created the virtual machine, as I've said, and we've created some specific hardware specifications. I've changed the hard disk as well as the RAM to make it quite good at running certain programs. I do advise to run it at 1 GB. I think that's a sufficient amount. And I've walked through the installations, and we've successfully installed Kali Linux. We've got to the login screen. Now we can look into Kali Linux and the interesting stuff that it has within it. So in the next video, we're going to be looking inside of Kali. We're going to be using Kali and sort of getting to grips with the certain basics of Kali Linux. So in the previous video, we looked at installing Kali and the steps that we needed to do to create a virtual machine. In this video, we're going to be using Kali, looking inside it and the features that it has provided for us. So we're going to be getting to grips with some basic Kali functions that it has. So if you're a Windows user, I just want to bring out some common command line options and arguments and command line statements that you can put out there for various things, really, and also some basic forensics with curl. Basically, we'll be sending HTTP requests and checking headers. So first of all, we need to log into the actual Kali system. So I've chose my username and the password I chose in the installation for Kali Linux, and then I'm just going to wait for it to load up. It'll soon load up the menu up top. It's a little bit different to Windows, as the Windows has the sort of applications menu almost at the bottom. But what we're going to be focusing in this course is the Kali Linux web applications section. We're going to be using some of the tools available in this subcategory of web applications. As well as that, we have the terminal, which is going to be fairly useful in this course. So we can choose the terminal from here, and then we can have some really cool commands to help us around the system. So ls is basically the dir option on Linux, and it lists the files available in this directory. We're in the root directory, so if we just go up one and see the system directory, almost in Linux, we see a few directories that are available to us. We can see there's a few things that we might want to check out and read through the console. So I'm just going to use the cat option, which basically allows me to read out the plain text available in that file. So it will do that. That can be great if we're just editing a file and wanting to see what's inside that file within the console. That's a really good thing. We can also make a directory and then see it available. There it is. We can also look at our network settings. Much like ipconfig, we can check internal IP address if we're going to be creating a web server here or we want to connect the two together. That's fairly important. And we've also got curl. Now, curl is a fairly important part of forensics at some points because it reads the headers of the connection. So if I use http ebay.co.uk and run that, we can see that the server header shows it's running Apache Coyote 1.1. This is the same with Google. And this allows us to basically get some information about the system. As we can see, Google has its own sort of system, GWS. And this is really great if we want to learn a little bit more. As well as that, we can just run a simple request to get a response. This is sending an HTTP request and we're getting a response. That's what curl is doing when we do this. I'm just going to do this. Google has a weird system, but this would be a 404 obviously, but it's been moved. Yeah, so that's what curl does. It's a really good, easy way of doing things. If you're checking responses of certain things, some vulnerabilities, you may want to check responses and not go into a web browser. Later on in the course I shall be showing a little bit more of curl, but I thought I'd give a little introduction into curl. We've also got this workspace and we can go from, that's not a great way of showing it, if I get console up and just ls, we can see we've got desktop here. If I just go past here, we can see we can switch and we can alternate between these workspaces, and this is really great if we are trying to work on different things or we have different tasks that we're doing and we want to alternate between the two very easily. This is really great. Also, we can hold and drag and move workspaces into different orders, which is a good feature as well. So in this video we've learned where Kali's core programs are, the web applications. They're available in the top menu, unlike Windows, which is at the bottom. We reviewed Kali's interface, we had a little look into the console as well as the workspaces that are available to us, as well as the menu that we had, and we also introduced ourselves to some command line arguments and commands. We looked at curl and also some few commands such as ls and ifconfig, and we used curl to retrieve headers and responses to introduce forensics almost, so that we can move on to curl later on, having a little bit of understanding of what it is. So in the next video we'll be looking at SQL injection, and we'll be in a new section, security vulnerabilities or website's worst case scenario. Hi guys, in the previous section we looked at the course overview, looking at the different parts of what's going to be in the course. We also had a look at me and what I do, and also we looked inside of Kali Linux, the different commands and features available to us so that you're able to start web penetration testing. In this section, security vulnerabilities, a website's worst case scenario, we will take a look at SQL injection, SQLMap, types of cross-site scripting, working with XSSER, and filtering and validation. In this video, we're going to take a look at SQL injection. We'll understand the concept of SQL injection and how it works. We'll also use curl to recognize a SQL signature. The reason we say SQL signature is because certain errors will show if our SQL injection worked. Errors that are associated with SQL errors are what we will define as an SQL signature. Not all errors are signifiers of injection though. So first of all, I've got average shop script up, and in the order.php there's obviously, if you go to home, we can see that there's products that you can buy. And once you click on them, you can go to an order ID, such as this one. So basically what I've done is I've killed the script and echoed out the command so we can all see what's going on. So in this instance, we have select everything from product where ID equals to 1. So everything within the table, which is product, which has the ID attribute as 1, select everything in that. The thing about SQL injection is we need to trigger an error, and the way to do this mostly is by looking at this ID here we've got. If we use another quotation, we've got two quotations here encapsulating this one. If we just simply add another quotation here, we can see that we have this stray quote on the right here which isn't really intact with anything else. It's by itself, and this would potentially trigger an error as we haven't fully filtered or validated any of the input that's going into ID. If we look at order.php, we just simply get a GET request, as we can see here from ID, and also we have the initial query I've got set here, select from product where ID, and this is where it's set, and we can see the quotations here. If we had the user input, which would do this, then we've got a single stray quote which would potentially cause an error because there's nothing defined to it. It's simply by itself. And the way SQL works is it will cause an error, and potentially we could append other things to it. So for example, if I simply put here, remove this, and from now on this here is the user input, if we just put 1, and if we put our quotation there, then we have a stray quote, and we can also append, as I've said, other things. So for example, a very famous one is and 1 equals, and we can just simply add another quotation and not add another one here, just have it as this. So the user input that we could put within the ID would be such as this, and this would create a always true statement. And this has happened before with logins. If they're not correctly verified, can log in someone that can bypass the authentication, or you can also do other more complex queries which could select data from databases completely, which obviously isn't great. You can grab details of various things. So we could append stuff to it if it's not properly validated, as it isn't here, as it simply just gets it from the GET request. Nothing else is put upon it. So let's show that as an example instead of showing it here. I'm just going to refresh this, and you can see now that we have some reviews. We actually have a description and a picture and also a title. So if we want to break the script and see if it's going to get an error, we're basically doing a test to see whether it has any validation. So we're going to add another quotation here. We can see that we get an error message this time, and this gives us a sign. It isn't always the case, but it gives us a very strong case to say that this is SQL injectable. So we're going to do another example, which is 1 equals 1, and we're leaving the quotation because we have the quotation that was supposed to encapsulate the user input, but because the single quotations are not filtered out in this query, it gives us the ability to use them in a certain way to append other things. So we're leaving that now to make sure that the SQL will now not break, it will not find an error. So if we do this now, it will find that it's always true, as 1 is equal to 1. But if we now put and 1 equals to 2, we can say that is false. 1 equals to 2 is false, so therefore don't do it. So these are some very simple commands that we can use to test whether it is SQL injectable. We're now going to go into curl and have a little look into how we can actually fasten the process. So first of all, we need to get a terminal up, which is available here, and we're going to basically be using curl like we did last time. But first of all, we need to know IP for our web server that we are hosting. I'm hosting it on my host machine rather than on a virtual machine. And I'm basically going to be first trying to set a SQL injection like that. And we can see that curl doesn't like that whatsoever. What we need to do is we need to wrap this in double quotation. And we'll see now that it comes back. But this is rather long. We can see the error here, but it is still really long. We don't want to see this. We need to use something called grep. So we're going to be using this character here to send the information from curl to grep, and we're going to put in quotations MySQL. Now in this page, we're basically searching for text that is MySQL. If you have a document about MySQL, it will find the text MySQL, and you may want to put another piece of text. If we look up here, a common error is, expects parameter to be 1, or warning, or something like that. So if you wish to do a different sort of search query, that's fine, but for now I have nothing on MySQL on this page, and so it is probable to just use MySQL for this reason. So it searches it, and we find that it's much easier. We don't get the whole page text. grep searches for us, and it finds a positive result, that it has found MySQL, which is here, and we can identify and now use another tool, or do it manually, to start using SQL injection in a productive way. So in this video we've learned about basic SQL injection and how we can identify it. We get that error. It can be different. It isn't always expects parameter to be 1. It can be something else as well, but we do get an error very similar to that. We've also used curl and grep to shorten the search so we don't have to use the browser in case there's visual elements in the way, or we just simply don't want to use the browser. The next video we'll be looking at is SQLMap, and that's going to be part 1 of a part 2 series. Hi guys, in the previous video we looked at the concept of SQL injection and how it is triggered, as well as finding SQL signatures using curl and grep and how visual elements might get in the way. We don't want to use a browser, and that's why we should use curl and grep together to find specific text. So in this video we're going to be looking at a tool called SQLMap. It's a great tool. It's part 1. There's another part of the series which I'll be extending with more information about. In this video we're going to be recognizing the command line arguments from SQLMap to enumerate and dump a database with SQLMap. It allows us to use it in an automated way so that we don't have to put much effort into it. So first of all I'm going to talk about SQLMap because I feel like it needs a little bit of credit. And it's an automated SQL injection tool. It has support for a lot of databases. There's a few there in the brackets. It's included in Kali. It's available straight away, so if you download Kali and open it up in a virtual machine or on a host machine, it will be available straight away. And the developers, which I apologise as I'm not able to probably say their names correctly, Bernardo Demelli, AG, and Miroslav Stamper developed this, and the website is sqlmap.org. So I've just opened up a terminal, like I said in the previous video. It's available here, and we've already fairly certain from the output that we've been given that there is a SQL injection within this program, this web application. So I've simply got SQLMap set here, and I'm going to use a dash and a H to set the argument of help. We can specify that we want help with dash H, and we can start the program by putting SQLMap in the terminal. So there's a lot of stuff that we can do, obviously, by this help file, and we can also look at a more full list of options, as we see here with dash HH. But for now, what we're going to be doing is we're going to be using a very simple command, SQLMap, and then specifying the URL. And I'm just going to enter the URL now. And because it's a GET request, as we saw in the last time with the code, we don't need to specify it in another way, and the reason why I'm pulling that up now is because we'll be doing that in a future, the next video, to show we can do a post request. But for now, because this is a GET request, we can simply enter this within the URL, much like in the browser, which you can enter a GET request within the browser URL. So I'm just going to enter that now because we've got it specified, and it will test for the connection to make sure it's correct. It'll find if it's dynamic and also try and identify the database type. It's found out that it's MySQL. It is incorrect in saying that. I do already know that, but if you do find something like this, it's a fairly good start, and unless they're trying to spoof their version or their type, then you're okay, and usually the default option of yes. I like the idea of including all tests just in case it's particularly hard, so you do want to click yes. If they do have some sort of IDS or firewall, which we may get onto later, then it may not be beneficial to use that option. But for the default simple option that we're doing here, we're just doing a very simple command here and a very simple test. It's simple, just use the default options of SQLMap. And this will start doing some methods available within its program to start finding SQL injections within the web application. And there's various methods and various ways of doing it that you may not know about, and this is why the automated process of SQLMap is good and bad at the same time. So as we can see here with this bright green color, get parameter ID seems to be vulnerable to a time-based blind injectable. It seems that that's working, and it'll basically try and compile all different methods that it has available to it, and will stop after a while after it's found a decent amount of methods. So usually it's around 3 that it will stop and think, yeah, we don't need to do any more. But it does ask you if you want to keep going. I don't need to. and then it gives you the methods available here. So we have the Boolean based blind, which I showed in the previous video, and also the union query and or time based blind as well. We're also given at the end of that the web server operating system, as well as the web application technology, as well as the backend database version. So now what I'm going to do is we could put this all in one query, but I've just done this step by step. We're now going to do dash current and then another dash and db, and this will specify what database we're currently in with this interaction of this page. So this page order.php is using the course database, and with that information we can now enumerate or show list all of the tables in the database course. We need to specify that with the uppercase D with a dash, and then the database name, which we've just learned, which is course. And I'm just going to enter that now, and we see that it retrieves the data back, and we can see here that there is product, review and users. And now what I'm going to do is I'm going to dump all by specifying the database. We could specify the columns, we didn't have to enumerate the tables, but there is various ways of doing it. I'm just going to dump all now with the database course, still specifying it with a uppercase D. And now that will grab data from product, review, users, the columns, and the data within them. So we have here ID, title, image, link, description. It will then grab these values available to it. And then it has the review. And there's another interesting table, users, which has username, password and user type. And if we let this retrieve the data now, we can see that it has it looks to be some plain text passwords which we could possibly use to log in. So we've grabbed all of the data from the database course, and there is an option to dump all databases available within this server, but for now it's just we're looking at the courses. There's no password hashes, which we'll get onto in a future videos, so it's just plain text passwords by the looks of it, which is just the characters R and E. If we use the username router and now put RE, we can see now that this option here, we can see we are now logged in. We have successfully found some data allowing us to log into an account. So in this video we've learned about basic switches in SQLMap, the U, specifying the database and enumerating the tables. There's many others. There's the columns, which we use, dash columns, as well as that you would need to specify the tables, but it was some very simple commands so that you can dump the whole database as well. And we've enumerated and dumped the complete database from course, the course database. We've used the data from database to log into an account, and this is the most interesting thing, is that we can do various other things in SQL injection. But we can also just gather information that we've got from this database, potentially harm other users because of this vulnerability, or gather information to potentially find other ways to get into or exploit the system that's available to us here. In the next video we'll be looking at some more advanced queries, SQLMap, in which it will be part 2. This is obviously part 1. Hi guys, in the previous video we looked at some simple commands from SQLMap have the ability to log into an account that we normally wouldn't have access to. In this video we're going to be looking at a lot more commands and some more advanced stuff, in quotation advanced. And so specifically we're going to be inserting a shell. We're going to have the ability to upload things by using the SQLMap uploader shell to upload other things. That will become clearer later on. As well as that, we're going to be identifying web application firewalls, or WAF. I say WAF. And we're also going to be making more unique requests with SQLMap to give us the ability to evade certain things if there's certain functionality, such as a user agent checker or some sort. So what we're going to do now is I'm just going to simply put in, as usual, SQLMap. I'm going to specify the host as per usual, and this time we're going to be using an automated shell uploader. And what it does is it simply tries to use common web folders and common techniques from SQL commands to basically upload a shell, which is SQLMap's shell uploader, and this will allow us, as we can see here, this will allow us to upload our own PHP scripts. So we are aware that PHP is the one, so we simply just press enter. PHP is the web technology that is on this web server, and it's going to try and do certain things in certain folders to upload. And as we can see, we got an error here, a critical error saying not authorized, try to provide right HTTP authentication type and valid credentials. But if we see here, we have something uploaded. This is different from I haven't showed this, but this is a different file. This shouldn't be here. Temp utnsx. Basic vulnerability here is we could put this into a folder such as an includes folder, which could show the web directory, and we could find the file. It usually is something like this, and we are able to upload a file, a PHP script that we could execute other commands to and access it in a much better level than we have with just an SQL injection. Another way of sort of doing that is first of all seeing if phpMyAdmin is available. A lot of web servers have it available, so I'm just going to input that. It's 0.5, not 0.6. And as we can see, if I just put an ending slash now, we can see that there is something there, and we are able to access phpMyAdmin from there. So now what I'm going to do is I'm going to ask SQLMap to get some passwords for me so I can potentially log in. So it's going to grab that. Now root here is, interestingly enough, doesn't have a password set. I'm going to go no there. And interestingly enough, course user, the database user that we have, does have a password. This is a hash password, but root doesn't have a password. We can just enter nothing. So if we now go to phpMyAdmin and then enter in login details, we are now available to go into the PHP. We've correctly been authenticated, and we can execute some commands from root. So an interesting thing we could do within root is do a similar but much more defined way of uploading a shell. So what we're going to be doing is we're going to be creating a backdoor basically. So if I just do a very simple backdoor into the system that allows us to enter it into an out file, and this basically puts this file and it creates a file within the system. And we know this is a Windows system, and so we're going to have to use 2 slashes here. And with our shell uploader, we can see we've got some retrieve the web server document root at the start here, cxamp-hdocs. We can find that out straight away, and we can use that workforce to specify where we want this. So now we've got that, we can just enter that in there, and this should work. And we are now able to execute commands, and we could potentially use this to get a shell onto the website or wherever we are on the web server. So now what we're going to do is we're going to be identifying and checking web application firewalls. So obviously the command for this is -- identify - web application firewall, and this doesn't take long because I don't have a web application firewall on, but it basically uses scripts to identify whether this has some form of protection. I don't have this form of protection at this point, but these are great if you're wondering the sort of risk level which we had at the start, where we were able to say when we wanted to extend all of the queries that were available to us once we'd found an injection point. If I just show you that you can set the level and risk as well, a level of tasks and risks to perform depending on what they've got. So identifying a web application file is sort of empirical if you have a sort of firewall set up in an environment such as this, because SQLMap in some circumstances could potentially evade that. Another thing we can do, which I did say could happen, was using post. Now this doesn't require a post, it requires a get, but for this example I'm just simply going to show this theoretically. So we have the URL set, and we've got the page order.php, and the command for post is -- data. And within that, we can put ID equals 1. We do not need the question mark whatsoever. And if we had something else like a submit button or anything that we needed to be set, we could put it in here. And we can put as many as we want. One thing to notice as well with multiple values, multiple entries into a request, is that SQLMap will always choose the first one to check as the vulnerable point. So if you have vulnerability, if you've checked the vulnerability manually, you may want to put the value first that you think is the vulnerable one. As well as that, we can change the user agent, potentially because you want to set it to a user agent that they want. There are some circumstances where an application may want to have a user agent of its own. It's been set. This can be set within SQLMap, as we can see here, -- user agent, and then we can move on with other points, such as dumping the whole database as such. We can also use the referrer if we need a specific referrer set, because if you're going through a program that uses a web application that needs a certain referrer, it could be talking to another API or web application or whatever, and it may need to require a referrer to check that it's from this site theoretically, and we can use the referrer to use and sort of defeat that protection that they may have. So what it comes down to is sort of the uniqueness of the web application and what it actually requires. In this video, we've understood how to upload a shell with SQLMap. We've done this with the OS shell command that's gave us a 401 unauthorized, but if we used this in a web directory which had no index file that we could view all the files, we could see that the temp file was there, and we were able to potentially get what we'd put there. What the 401 unauthorized is trying to receive and check that it's there. So we've also learnt how we can identify a firewall within the web application using the -- identify web application firewall, as well as -- check. And we've also made more unique requests that some applications may require, such as the user agent and the referrer. In the next video, we'll be looking at XSS, which is cross-site scripting. Hi guys, in the previous video we looked at advanced SQLMap queries. This included a shell where we uploaded, and we were able to upload another one. We were able to get into PHPMyAdmin, we were able to change the user agent, and we were also able to identify, if we had one, a web application firewall. In this video we're going to be looking at learning the concept of XSS. This is cross-site scripting. We're going to be looking at practical examples and also understanding the different types of XSS, which is cross-site scripting. So there is two main cross-site scripting types that I want to go through in this video. So there's stored XSS, which is held within the server. The payload is then retrieved back once it goes on a certain page or a certain characteristic happens. A good example of this, which is going to be shown, is a comment system where you enter an XSS payload and it is stored within the database, and then when someone loads that order page, it will be executed because it's been retrieved back from the browser. Another one is a reflected XSS, where the user input is echoed back to the browser on the page load, so the GET request is put within the page. And an example of this is having a full URL on a website shown. So the full URI, the requests, that I see a lot of that sort of XSS. So there's a few diagrams, well there's two diagrams here. We've got stored and reflected. So basically the main difference is you have the input from the user, it goes to the script into the database, and then there's another part which is if they load a page, the script will load onto the database and it will come back and it will output it, and then the user will get the cross-site scripting executed. This is JavaScript essentially. So one thing to notice in this script that I've simply done is I've got ID, which we looked at last time with the SQL injection, and we've got it echoed out here for this example. And what we can do here is we can edit this one and we can put something like script alert, and end it with the script tags. And what that'll do is it'll execute the JavaScript, because what we've got here is the script tags, and it's actually executed this user-side code. And what this can be used is we can put script source and we can potentially find out various information, redirect a user to another site, amongst other things. So it is fairly dangerous that this is available, because we can change elements on this screen because we have the user side instead of the server side, which is different. A stored XSS, basically, as we can see here, we've got a 1 to 5 review, and then we've got some space with description. If we add something like script alert, script, and rate it, first of all it executes here, but now if we just log out and actually go on to another user session. So what I've done is I've removed and logged out by removing the cookies. If I now go onto the buy section, we'll see now that it's executed and I'm not logged in. This is because it's stored within the database. This is a stored XSS. It hasn't been filtered, this user input, and it's simply been executed. So in this video we've understood the concept of XSS, the cross-site scripting. We've viewed examples of XSS. I've done the ID where it's echoed out, that feature that I've just added on for the example, as well as we've got the stored XSS, which stores the description in a database, and I've added script alert, and that has basically made it available to everyone else. Even if you're not logged in, if you just view the product page because it's there, the reviews, it lists it all, the JavaScript gets executed. And this is dangerous as we can do many things with JavaScript to affect the user. So we've found some distinction between stored and reflected XSS. In the next video we'll be using XSSER to detect and use these vulnerabilities. Hi guys, in the previous video we looked at XSS and the different types of XSS, so we had reflective and stored, and how that could be used potentially by redirecting to another website to harm a user. In this video we're going to be looking at XSSER. XSSER provides us an automated version, much like SQLMap, to identify XSS, cross-site scripting, vulnerabilities. So specifically in this video we're going to be getting started with XSSER, learning about the different features that it has available for us, and one of them things is reports. It puts them in different categories, so we have suspicious, failed, and successful, and these are a really good way of sort of narrowing down so it takes less of our time. It also provides us with features such as proxies and bypassing anti-XSS filters, which are fairly interesting and exciting if you are testing your web application and you haven't as much knowledge as you should on XSS payloads, because this program provides many. So first of all, to find XSSER, you can go to Applications, Kali Linux, Web Application Fuzzers, and XSSER. Now this provides a command line version, but there is a GUI version which is much easier for beginners, and also some people don't like typing out stuff all the time, so --GTK is how we can bring up a GUI version of XSSER. Now, before we start looking into the different features, there's one feature that I should start with. It's that once we hover over a feature such as this, it will tell us with a little tip what it is. So this is in fly mode. It's telling us if we choose intruder, it will test your target URLs directly. The Explorer will basically search the internet to search for vulnerabilities. We don't want that. We're going to be using a specific web application on a specific place, so we're going to be using intruder. So we want to tick automatic, as this provides us with more payloads, and we also want to choose crawler, which will basically go around your site and find various places to try payloads. So now that we've got them all set up, what we can do is click aim. And now it's got a whole lot more options, and these are default. Don't worry about that for now, that is fine. Now we can click fly. Now while that's doing a scan, a crawl, and looking at its payloads and trying to execute them, if we go to Expert Visor here and go to reports, we can see there's some some various entries here that we have that are keep being updated. Now these suspicious ones are that they've come back, but we're not fully sure if they're executed on the browser. That's the pinnacle thing of XSS, that it can be brought back, but it's got to be executed so that you can successfully have JavaScript executed. That's just how it will work. Vulnerables are for sure vulnerable, and XSSER knows this. Failed is that it didn't work and you shouldn't try it at all. And there's also errors and crawling, and the crawling obviously shows where it's been. So style is not vulnerable to XSS, but because it's in the suspicious tab, it's somehow come back. So let me show you how that looks like. So as we can see here, that it's come back with a version of what it has as a payload, but it didn't execute correctly on the browser to provide us any sort of JavaScript that we could possibly execute. ID, though, should be able to correctly execute JavaScript code. So if we just highlight that and execute this, we'll find that actually it is working. This specific payload showed that it could execute this hash value, and if we actually done this to the style, we can see that it still doesn't execute. And the reason why I did that is some people might question, well, the other one wasn't really JavaScript, it was just some text, and so I thought I should show that. We have some suspicious payloads that correctly or should correctly execute, and this narrows it down for us. This provides us a great automated way of finding payloads that do get through, and we just need to test these types. We also have bypassers, like I said in the presentation, which allow us to do various bypassing methods. So we've got unescaped, decimal, dword, and we can tick as many as we want from here to make sure that we can bypass the filters that may be available within the code. So we can also set up a proxy, which is available here. I assume it is a HTTP proxy, and this allows us to maybe evade our original location. As well as that, we also have Tor down below here, which I believe you would have to set up with the socket that you're available on. Much like SQLMap, we can change the referrer if there's a specific referrer that is needed, and again we can also change the user agent to set if there is a specific user agent that is needed. So in this video we have fired an XSS attack on XSSER. We have used multiple payloads through an automated process that has allowed us to narrow down and find specific payloads that work for us, whether they have bypassing on them or if we have just a plain old payload that's been provided which XSSER has tried out. We also have verified this XSS vulnerability with Iceweasel, and the most important thing is that we can't do this really on terminal, because the only real way of finding out is seeing if it actually executes on the web browser, such as the alert function, because we can see that it's actually there, like the style situation I showed, the circumstance, is that it can sometimes be echoed out but not actually executed, and that's why it's in the suspicious tab. And we've understood XSS's core functions. We have some tabs available for us, and we can navigate around them to, define the user agent, the referrer. We can set a proxy. We can do many things. We can also bypass to successfully get an XSS vulnerability from our web application. In the next video, we'll be covering filtering and validation. Hi guys, in the previous video we looked at XSSER and the different features it had available to it. It had bypassing, and you were able to change the user agent referrer, you were able to get a proxy, you were able to crawl the website. And in this video we're going to be basically looking at filtering and validating user input. So the vulnerabilities we've covered so far have been XSS and SQL injection, and we're going to be showing how we can filter these so the characters that break or trigger the vulnerability won't occur, and we're able to actually just carry on and use that user input. Also, we're going to be looking at validating user input, specifically the length. That is the most important. We're going to be understanding the importance of being cautious with the user input. People think if you filter out the greater than and less sign that you are fully safe from an XSS injection, and this isn't really true. You should be using HTML special chars because there are, in some cases, if you're in an element such as input, where you can use actions like on mouse over or on load to trigger JavaScript function or to alert. So the XSS isn't fully safe if you just simply remove these tags. So the reason why we've got this string length and checking if it's lower than or equal to 4 is because initially we're not going to have a lot of products. We're not going to have over 9,999 products. So really, we could actually reduce it to further characters. But what this does, and it shouldn't be the only form of protection, but it means that with SQL injection, you need a fair amount of characters. And if there's only 4 available, then you really can't do anything with it. As well as XSS injection, you can't really do anything with it because the length has been specified and it's a short amount. Obviously, if you had something like 20, maybe you could get inventive. With XSS, it would be much easier. With SQL injection, it'd be still a little bit hard. But the limiting of length is a good idea for a first area of defense. And then we're basically saying that we may have some special characters in here and we want to put them so that we can echo them out but not have them executed in the browser. The one thing that I would advise to use is HTML special chars. It filters out all the special characters that shouldn't be there, so quotations, greater than and less than signs, and this helps us in making sure that it doesn't execute on the browser side. Now, it does come back, the characters, but not in the way that it will be able to execute JavaScript. So if I just show that. So what we've got here is we've got script alert, and I've done this in order already. And as we can see, it's a little bit longer than it should. The length is longer than 4, so the parameter is incorrect. So without even protecting against XSS, by using the HTML special char function, we've got an area of defense. So this is a good start. So if I now remove the length, so as we can see here, now that I've removed the length, that now it echoes out, and it should actually execute, shouldn't it? But if we go to the source, we can see that it has HTML entities, and this makes it sure that it will show it on the browser, but it won't necessarily, well, it will not execute from the browser because it's had the HTML special char filter out and change these so it doesn't execute. This is what we want because it makes sure that special characters don't interfere with the browser and how things interact. This is a fairly deprecated way of doing interacting with the database, so I'm going to just skim past this for now and do this very fast. But you can use the function MySQL real escape string to escape a string for the MySQL Connect functions. Basically, with base, if there's a quotation, it will try and escape, well, it will escape it, and I've used the user input ID, and basically I've echoed it out. So if we just go to the order page and enter a quotation, we can see that this slash here, which basically cancels out one of these quotations, means that it's actually a normal query now, that it actually isn't broken and it will work. Now that I've uncommented out the execution, if we just go back and see if it runs correctly, it should completely ignore the quotation now and just run as normal. As we can see here, it does. It has the description, the picture, and the title, which means it has got the correct, and it has ignored the quotation. So basically, this is some basic example PDO PHP code that I've put up. It's theoretical. I'm not going to show how it works. It's just a query, and it's using a prepared statement. That's the sort of technical term for it. And MySQLi also has prepared statements, and basically it's binding the parameters depending on how many you have. And what it's doing is it's basically telling the database server that this is going to be data, whatever this is. So SQL injection is very unlikely because it's always going to be interpreted as data. The database server should understand that this user input or this input from this variable should be data, and so the specific sort of characters such as a single quotation are ignored. In this video we've correctly filtered SQL and XSS injections. Now we looked at prepared statements in SQL, the theoretical scripts that I provided in the video, and basically that's the best way really that you should be implementing user input. You should be using prepared statements instead of using MySQL real escape string, which is rather old and dated now. As well as that, we looked at XSS injections and how we can use filtering to the specific function HTML special char so that it still shows in a browser but it isn't echoed out as it executed. It is basically using HTML entities, the and the characters with a semicolon to make sure that it doesn't execute. We also validated user input. In this one I showed in XSS, which basically checked for the length, because our actual feature is really, we're not going to have a load of products, so we don't need a lot of input into that. And we learned to be cautious with user input, because you can never be too careful on what sort of input the user may provide. So in this section we've learned about XSS and SQL injection, and we've also understood validation and filtering. So we've used XSSER and SQLMap, and we've also understood the importance of user input. What these two vulnerabilities show is that, you know, whatever the user puts in, you should check rigorously with validation and filtering to make sure that nothing can happen, such as an SQL injection and an XSS injection. So we're going to be in another section in the next video. It's going to be no file is safe. Hi guys, in the previous section we looked at injection, specifically to do with SQL and XSS. We also looked at some tools to utilize these vulnerabilities to detect and go a step further. Now we are in section 3, and in this section we're going to take a look at LFI and RFI, FIMAP and directory traversal. In this video we'll talk about local and remote file inclusion. We're going to understand LFI and RFI, which stand for local file inclusion and remote file inclusion. We're also going to look at a practical example and the difference between them. So first of all, what is RFI? Well, it stands for remote file inclusion, as I've said before. And in this certain vulnerability, it uses the include or require function, which is usually used in a theme way, and it uses a GET request to get a certain page usually, and this provides us a vulnerability because it means that we could potentially call for other pages that weren't supposed to be called, but because it's a GET request, we can have the user manipulate how it's done. More will become clear later on. It allows a remote file to be included, so somewhere outside of the server, include code or whatever text outside of the server to be executed. And the request is usually a folder. I've got a screenshot here showing a remote file inclusion example from a recent exploit found in a WordPress plugin. So we have the folder here, as we can see the slash, we've got the user input here, the GET request, and what that allows us to do is define the protocol, and that's the biggest thing in this, is that the protocol is used to define where the require should be. The thing with remote file inclusion, as I will talk more about later, is that PHP has restricted the usage of this and it is much harder. LFI stands for local file inclusion. Allows a local file to be included. The difference between them, as we can see already, is quite clear. Remote file inclusion, you go outside the server, you get the code from somewhere else, and local file inclusion, we're including files from inside the server. So for example, I've put in brackets here, we've got the password file that potentially you could grab to use in various ways, and what the third bullet point here, use ... to go back from web root, is it will become more clearer, but we can navigate our way around the file system by using these to find files potentially. The request is usually for a file name, unlike RFI, which is a folder. In local file inclusion, it will use the page, so we can't define the protocol, but we can define where the file is. So in average shop script, we've got a theme-based system, and it's asking for a GET request of style. That's the name of it, and we're putting the variable theme to it, And if the theme equals blue, then we go to themes blue.php. If it's black, we use themes black.php, and then we call require once theme. And there's potential to exploit this, because if it doesn't equal to either of them, we can define our own folder and file name and say where to go. So we're in the themes folder I've got here, and what we could potentially use is .. allows us to say we want to go up a folder, so we would go up to here if we use .. here. But first of all, let me make things clear on the local file inclusion. If we just include a dot here, we can see that it's given us an error because there is no file called dot in the themes folder. We can specify the page name and the folder that we want to go in. First of all, though, we will be in course, so because we're defining themes here, we could potentially just leave themes there and navigate from there. So, and in a real world situation, you would use trial and error. You would keep doing the .. till you reach to a certain point. So with the themes folder, we have to just go up by counting here. So if we go 1, 2, 3, 4, 5, that will go to the C drive. And I'm just going to simply call this, I'm not fully sure what this file is, but I'm going to call this and see if it loads. See, as we can see here, we've got what seems to be something to do with Microsoft Visual C++, and basically that's been included inside the PHP. The theme has disappeared, obviously, because we don't have any of that. We're simply including two files together. And the example I gave as well, the password file for Linux, would be a primary example of how this could be dangerous. Like I said a few moments ago, remote file inclusion, you need something on in the PHP config file. That is, allow URL include. If you don't have this, stuff like HTTP or FTP, if it was inside the require or include once, then it wouldn't allow it whatsoever. It would break the script and it wouldn't work. So what I've got here in Pastebin is a system execute. It's a simple execute command code. So what I'm going to do is I'm going to include this in style, and this should work because we have included, as we can see here, we've included from a remote file, because the PHP allow URL open function in the PHP config file, because that's enabled, we can define in here the protocol where it is, and this is basically included and appended with the code from login.php. So as we can see here, it will say undefined index C, and we haven't executed something. As we can see, this is true. If we actually just put in here and see who am I, it's grabbed it from the Pastebin server and put it and appended it with the login.php and allowed us to execute commands. In this video, we've discussed the concept of local file inclusion and remote file inclusion. We've looked at examples of remote file inclusion and local file inclusion, and we've also understood the difference between RFI and LFI. In the next video, we'll be putting this into practice. Now that we've fully understood the two, we're going to be using FIMAP to find vulnerabilities and exploit them. So in the previous video, we learnt a little bit about remote file inclusion and local file inclusion. We're still in this section of no file is safe. In this video, we're going to be looking at FIMAP, which is 3.2. So the main parts of this video is we're going to be reviewing FIMAP's features. We're going to be using FIMAP to find vulnerabilities within our average shop script. I'm also going to spawn a shell using FIMAP. So FIMAP is a Python-based tool to find remote file inclusion and local file inclusion vulnerabilities. The creator of FIMAP is Iman Karim, I hope I got that correct, and his Twitter handle is @FIMAP. It also has a plugin system, which is pretty cool actually. A lot of tools don't have a plugin system, and it's quite refreshing to see that. So like most Kali programs, FIMAP first starts with the program name, so its name is FIMAP. If we want to go to the help screen, we use, like most of the Kali programs, -h. Please take into notice that uppercase H is actually used in FIMAP. It is used for harvesting. It is quite similar to other tools that we have used in the past. There is the -u, which is URL, and basically you need to provide some parameters as well. Our RFI vulnerability that we know of is in style. We are aware of that. FIMAP is actually relatively fast in finding the vulnerability in this way. So I'm just going to press enter. It's going to fiddle around with the URL and it's going to notice some things, try and test various vulnerabilities, and then we get this little report which is also held within the local system and not just command line. It does save it to the file system. And we can see here we've got the URL and we can see the parameter, which is style, the path that we will have the vulnerability in. It's correct in saying that we're in the inc folder. So the next thing that we can do is actually we can spawn a shell. So the interesting thing about a shell is that we can execute system commands, and I've put the end of my previous command line, so I specified the URL, and then I've got -x, and what it said here is the list of domains that we have currently which are available to do this. We just want one, so we're going to put that. And also the URL, you can have a specific URL that you're going to use. In this one I've only specified and scanned one URL, which is order.php, so I'm going to be choosing that. It's going to test a few things to open up the vulnerability, and we're also going to be choosing our attacks. Now with the plugin system we can have various attacks, but by default we only have one, which is the FIMAP shell. So if we choose that attack, and there we have the shell. If I just put a simple Windows command, who am I, we will notice that it comes back with the correct response, which is what I've done before, jack-pc jack, which is the user for that process. So one interesting thing you can do in FIMAP is you can also mass scan. So I have a URL list here which specifies basically the same thing, except it's got a different page. So I've got the index and the order page, and basically what we can do is we can say to it, scan both of these within the same command line. So basically we're doing multiple scans because we've specified the list. So if I just enter this, it will notice where it is and it will start looking for vulnerabilities. So it can read the URLs. You basically have to just put them into a different line, much like any other URL list that you would find anywhere else. So if we just clear this to make this look a little bit better, if we go to FIMAP and say install -plugins, it'll basically look for a list of trusted plugins that are available to you. So we have two that are available to us right now: Weevil's Injector and also an AES HTTP reverse shell, which you can use. So in this video we've used FIMAP to exploit a vulnerability. We've used it with various commands to understand how we can navigate our way around, doing mass scans or a single URL. We've also spawned a shell to execute system commands, and we've also retrieved possible plugins to be installed. In the next video we will be looking at directory traversal. So in the previous videos we have used FIMAP. We've used it to find vulnerabilities in file inclusion. So now that we've done that, we can look a bit into directory traversal and what the difference is between the two. So in this video we are going to be looking at understanding the difference between file inclusion and directory traversal. A lot of people don't fully understand the difference and it can be confused, so that's why I want to clean that up in this section. We're going to also learn techniques to combat all of these vulnerabilities, be it local file inclusion, remote file inclusion, or directory traversal. We're also going to look at a practical example of directory traversal so that we can understand a bit more about it and solidify our knowledge between the two. So file inclusion reads and executes, while directory traversal simply allows someone to read the resource as it would be defined. So for example, if we had a download script that allowed us to download a file, maybe we could use the same sort of techniques that we used in local file inclusion and remote file inclusion to go up and down in directories with .. We could download files that normally we wouldn't be able to. Directory traversal can also be known as path traversal, but is commonly known as directory traversal. So what I've got here is a very simple script that I've added to the average shop script. Let's just say that the people that made this script would want some functionality to download PDFs, but they haven't fully validated any of the input that has been put into the script, and so it could be easily used to a directory traversal attack. So for example, we could potentially with this script download our own script, get.php, and the attacker could read the file, the source code within it. Now this may be a problem for us because they could find vulnerabilities within other pages if they are aware of other pages. They can also read the config files, which could potentially mean that they could access the database. Now, one way of fixing this local file inclusion and remote file inclusion is to include an array of files that you're aware that you want to be accessed. Now, what we could do is we could have a database. Potentially, if this was a large-scale project, we could have a database which uses a loop to verify that these files are actually the files we want to download. For now, I'm going to be using a small-scale array of files to show what we want downloaded and what we don't want downloaded. So what I've done here is I've simply added an array. So we've got allowed files as a variable, and the array contains shipping.txt and pr.txt, which we have in our file system here, pr.txt and shipping.txt. And what I've simply stated is I've used the inArray function in PHP, and I've basically said if the GET request says shipping.txt or pr.txt, then we download that file that is coming from the GET request. Otherwise, we say no such file. So what I'm going to do now is I'm just going to simply enter get.php, and as we can see, it isn't in the array, so it will simply state no such file within the array as it is, but it's echoing out no such file. If we now put shipping.txt, which is within the array, it will grab it, and it will grab the file and allow us to download it perfectly fine. So in this video, we've understood that directory traversal and file inclusion are different. We've also had a really simple example of directory traversal through the download script that we've created, and I also showed you how you could combat attacks with an array and looking at the array, but you could also move that on if it's a large-scale project, looking into the database and seeing whether it contains that value. So in the next video, it's going to be hash brute forcing, and we're going to be in another section, which is avoiding forced attacks. Hi guys, we're in a new section now, avoiding forced attacks, which is section 4 now. And in 4.1, we're going to look at hash brute forcing. We'll take a look at hash brute forcing, hashcat, form brute forcing, and Hydra. So in this video, we're going to be looking at why you should not use weak hash algorithms. We're also going to look at brute forcing weak hash types, and we're also going to look at consequences of brute forcing. So hashing passwords. Basically, hashing allows us not to store plain text passwords in the database. It allows us to give a different value to put within a database, which could be correlated towards that password. Weak algorithms like MD5 and SHA-1 can be decoded trivially, and so I absolutely advise no one to use MD5 and SHA-1, even with salts. So constant research into new hash types and technology is advised by me. If you're creating a web application or whatever application you're creating, it's always best to upgrade to whatever you think is suitable. Don't go into a technology too fast if it's fairly new. Look at papers and make a informed decision, research heavily into new technologies. New PHP versions support bcrypt well, which I favour and I think people should use. Salting can aid in dictionary attacks if correctly implemented, and I'll be talking more about these in detail later. So the developers have accepted that some parts of the system is vulnerable in average shop script and have decided to use the MD5 hash algorithm to hash the password that's given to them in the register and also the login process. So what it now does is it checks if the hash is correct within the database. I've got a password set as test, a very simplistic password I know, but it's just for an example, and I've also got the username test entered here. So I've just copied the hash to hashkiller.co.uk, which is a popular site for decrypting MD5. And we can see that it has found it as test. And what hashkiller.co.uk has done for us is it's basically done all the work for us. It's basically used every single possibility it has within its cracking sort of process to find a valid plain text word or combination of words or pattern to successfully decrypt it and give it the plain text. So what it's got here is it's found test. Now test is a very generic term, easy to use. So in word lists, which I will talk about more later, would have included test as it's a very easy generic password that a lot of people use. And they've correlated the hash between the plain text and found that these two are the equivalent of each other. So it's basically done it all for us, and then it's searched its database of current decrypted MD5 hashes, which is at a large amount at this time, and it's found that yes, they have cracked this hash and it is test. So that is what brute forcing is. It's finding every single possibility, be it a word, a pattern, or whatever, and what it's done in this instance is it's gone through its database of successful decrypts and it's given us it. So in this video we've looked at the concept of hash brute forcing, and we've basically seen that it's searched for different patterns, be it a word list or a combination of letters, numbers and symbols, and it's found that one hash, which in our instance was the test MD5 hash, is in correlation with the plain text test. So at some point they've said search the MD5 for the plain text test and it will come back with that specific hash. And they've kept that in a database saying this is what this is, and people are now able to retrieve that information and find out that yes, it's test. Also, we can now realise the potential consequences that may occur within brute forcing. So if they have this information, they could potentially log in as an administrator if they've decrypted a hash password that was an administrator's, or they could get to another level of access that they potentially couldn't get to. In the next video, we're going to be using Hashcat, and we're going to be cracking passwords by ourselves without the aid of hashkiller.co.uk. Hi guys, in a previous video we looked at the sort of concept of brute forcing, especially with hash brute forcing, and we showed the consequences of what could happen if a attacker can successfully crack a password, in which we used the website hashkiller.co.uk. In this video we're going to be looking at Hashcat. Hashcat can be used to crack passwords in replacement with the website that we used. This could be a possibility because the hash isn't available on the database or it hasn't been found yet, because there are almost an infinite amount of possibilities with passwords. In this video we're basically going to be looking at Hashcat attack types. We're also going to be talking about Hashcat hash types and how we can change that, and we're also going to be discovering Hashcat command line options available to us in the command line interface. So these are the available Hashcat attacks that I would use commonly. There are much more available to you, but these are the common ones that I would use. They are the combinator attack, the dictionary attack, and the permutation attack, as well as the mask attack. So first of all, the dictionary attack reads words or patterns from a text file and correlates them with the hash to see if they are the same. Word lists are effective for passwords which use commonly or even slightly common words used for passwords. This can be effective if an attacker has a whole database in possession, because at least one user will have a poor password. That's if the validation procedures within the registration in the application don't have the correct sort of procedures. So, for example, max length, whether they have a symbol in it or not, whether they have numbers, uppercase characters, lowercase characters, just a combination. Having that sort of procedure sort of defends users from this sort of attack. The combinator attack uses all words included in a dictionary or word list, which we talked about in the previous slide here. There are a load of words are given in a single list form, and they are hashed to see if they are the same. Combinator uses this word list. So, for example, here we have 1, 2, 3, 4, and 5, 6, 7, 8, and then it puts them together. So we have 1, 2, 3, 4, 5, 6, 7, 8 as one, and we also have 8, 7, 6, 5, 4, 3, 2, 1 as one. So a mask attack allows us to define certain key spaces. Now, I've put key spaces in bold because you may not have heard of it. It's a different term than you may normally have heard of, and basically it could be a lowercase, uppercase letter, it could be a digit, it could be a symbol. And we can define these different types, lowercase, uppercase, with certain symbols like the question mark and L is letters, the question mark D is for digit. So this would mean that it would search for these different sort of character sets that we have available. So it can, in short, it can define specific limitations for brute forcing the password. And this can save us a lot of time. For example, we know that usually humans usually choose to have an uppercase letter at the start of a password, the first character, and then goes down to the lowercase. It's just how human password interaction happens. So things like the mask attack can save a lot of time compared to traditional brute force attacks that normally would have taken place. The permutation attack uses characters from word lists and changes the pattern. So in this we have a example that's 1, 2, 3, and single characters are changed to give different sort of combinations within the actual word itself. So I've given some examples there down at the bottom there, which you can see. So I'm just going to give some very simple examples of how to use these attacks so that you can use them in a real situation. So what I've done is I've simply generated a SHA-256 hash on DuckDuckGo, and it's basically the word hash is the SHA-256 hash that we have, and I've put that in a text file and it's there. This is going to be the hash file that we're going to be cracking with our different methods. So what I've done here is I've created a folder on my root directory so it's nice and clean, so we have the hashes all together. That's basically why hashcat is on that screen right now. But what we can do is first of all go on hashcat and then -- help, and that will print a load of options. Now the first thing that I want to talk about is the hash types that are available to us. Now we basically have to define to hashcat what sort of hash we have in hash file. So at the moment we have SHA-256, which is the number 1400. There are other combinations such as the pass and salt, but we have simply put in hash. There are specific ones as well, such as Joomla and Skype and various hashes that they've been able to look at. We're staying simple with the hash type SHA-256, and so we have to define that in command line. So we have attack modes as well. So we have 3 brute force, which is mask. And then we have 0 straight, which is used for dictionary, as well as combination and permutation, which we have here. So now that we know a little bit more about the command line options, I've basically stated in this command line that the hash that we're going to be looking at here is SHA-256, and the attack type we want is mask or brute force, which is number 3 here, -A. And we're also defining where the hash is, so we didn't have to put root hashcat hash. I've just done that to show you the directory that I'm in. In Kali it doesn't really matter anymore. In Backtrack, the earlier versions, it sort of did. And then we've got this mask here. This is what masking is. Basically, this defines what the hash may have. So L stands for letter, so hashcat will search L, any type of the alphabet, A, B, C, D, E, F, G. It'll go through all of that. And then what I've done here is I've said output this, the results basically, into hashes.txt. So if we do that now, it'll initialize and it's come back with some results. And as we can see here, it said recovered. So here we have hashcat.pot, which is used by the hashcat program to store some files about the hash basically and the combination. And if we go into the one that we wanted to output, we can see here that we've got the hash as well as the plain text version hash. So it's found it correctly with the mask that we have created. Just to sort of better define the masks, we have in the help page some help here. So the letters here, it's gone through all of these, but we could have, if it was uppercase, we could put U, or we can create custom character sets to create a combination of all 3 of these to make sure that it goes through the right combination. So I'm going to just delete these, and then we're going to go on to the word list, the dictionary, which is attack type 0. Basically what you have to do is, it's very simple, very similar. We're defining the hash type, we're defining the attack type as 0, we're saying where the hashes are, but this time we're also stating where the word list is and then outputting it. So in my word list here we just simply have hash, and this will be a relatively fast process as it only has to check one thing. So there we go, it's found it correct. If we go back to the folder, we will see that it's got again hashcat.pot and hashes.txt. We check, it's got the same thing, it's found it, it's recovered. Now that was relatively fast because it only had one word in it. Now with a combination attack, what we can do is we can split these up into different files, and this will go, it will choose all the available possibilities that it will have within here. So it will find hash in a reasonable amount of times. So if I just do this and it finds it straight away, we can see it's recovered 1 out of 1 hashes. And if we check again, in the hashes.txt, we can see, yes, it's recovered it. Now with a permutation, it does it by word. So I'm just going to put that. I've saved that. So the permutation is attack number 4. And if I just enter that now, we'll see it's recovered it. It's found that the different combinations of the letters will enter as hash. And if we go into the directory, we will see that successfully it has put it in the right order and it has found hash. So in this video we've looked at the concept of hash cracking with Hashcat. We've seen the different sort of attack methods that are available to us. We've also successfully staged attacks on a SHA-256 sum. And we've also understood basic Hashcat commands. So the mask letters. We've also understood that there's different hash types that we can define, and there's also the attack types that are all different: permutation, combination, dictionary, brute force. In the next video, we'll be moving on to form brute forcing. Hi guys, in our previous video of avoiding forced attacks, we looked at Hashcat and how we could crack passwords. So in this video, we're going to be basically looking at form brute forcing, which is another type of brute forcing. So specifically, we're going to be looking at what brute forcing actually is, how form brute forcing can affect users, and the solutions to form brute forcing. So first of all, I want to bring up a case study. Jennifer Lawrence was targeted to retrieve photos from her iCloud account. The use of poor passwords gave her access to unauthorized users. So, you know, that was her fault in that way, that there was such a short password. It was a pet name and number. But it was also Apple's sort of fault that, you know, there was no rate limiting. I do believe that brute forcing was the reason that this was able to happen. I do think that most likely what happened was scraped information was done about Jennifer Lawrence and they brute forced her account. There was a tool on GitHub that had a proof of concept showing you how you could brute accounts. What form brute forcing does is, in a web application, it will do any combination, any sort of pattern. So like in Hashcat, we had different combinations like admin. It would do that, but in the form sense. So we would keep just running a script to check if login details were valid so that we could potentially log into someone's account if we knew certain information about the person. So in this case, it was her email that they were able to get, and then they were able to brute force her password to get into the account. So with form brute forcing consequences, I've narrowed them down to 3, and that is easily able to access accounts with no other vulnerability. All you need is to find the right password or username and you're able to go into someone's account. There's no other vulnerability involved, while other things, such as Hashcat, would need another vulnerability to get the hash in itself. That's what I mean by that. It destroys users' privacy, and in Jennifer Lawrence's case it was photos. In other cases it may be financial information or just information you wouldn't want publicly. And in some cases it can cause a denial of service. Now, you know, it isn't a conventional sort of example of login details being a case of denial of service, but other cases of forms which don't properly validate the user input could cause a denial of service with a complete keep brute forcing information into there. So there are solutions to form brute forcing, and before I start I do want to say that you can't rely on one thing and you shouldn't be fully satisfied with having security. You should always be checking and always be paranoid for your users' data that is quite important to them. So the first one I want to talk about is capture, and people use capture, but I don't think it's the only thing you should use. You know, a lot of websites use capture and that is it. They have no other line of defense, and there are anti-capture measures out there. So that is why I think you should look in other places other than capture with brute force solutions. So there's also rate limiting, which is basically if you log in with the same account name or username in within 1 minute or whatever, and you get 5 incorrect details, then you should be blocked for about half an hour, be it an IP or anyone trying to log into that account. Rate logging goes in tandem with that. Basically what I mean with rate logging is that you log all the details, and if there is such thing as 5 incorrect login details, then you can log that data and look at that IP, look at that user agent. Is it normal? Should it be blocked from the website? And also, should we email the person, the emailed account, and say, we think maybe there's a possibility that someone's trying to brute force your account. Could you please change your password to a more secure password, and then provide some details into how to create a secure password for their security. And the last one is intelligent location check. If their IP address is not normally that. So if you're rate logging and you're logging the IP and then you see that they're possibly logging in from a different IP, a lot of financial companies will use this. They'll also use browser fingerprints, but then you should email the user and ask them, is that actually you? Could you verify that via your phone or your email, so that there's a second line of defense in case they have got in, but they're logging in from a different area. So what I want to do now is I just want to show a simple example of the average shop script and how using capture could potentially help you in a brute force situation. So I've made a little program to show you guys, first of all, the average shop script and how capture can work. So first of all, I've got password.txt and users.txt. They have the same values in them. They are just generic username and password values. Basically what brute.py will do is it will brute force the application average script, average shop, to find logins such as it has here, success login, admin, and as well test. And it has found this. This is because there is no capture or any rate limiting or logging or location. It has just simply got nothing involved protection-wise towards brute forcing, which means that my program was able to find these details, which we could log into. So now I've implemented a capture, and when I log in with some valid details, I will come across with a capture such as this. So let's now try use my program to try and brute force the login. You'll see that the admin combination now doesn't work, and so does the test hasn't worked, and there has been no combination has worked simply because the capture has been able to defeat the request by not doing anything towards the capture. It won't move on to the next step. So in this video we've understood the basics of form brute forcing, and we've also discussed various solutions to form brute forcing. We've also looked at the consequences of poor protection towards form brute forcing or web applications in whatever way. It doesn't have to be form brute forcing, but this is the main one that we're talking about today. In the next video we'll be using Hydra to brute force with forms and using it in Kali. It has a lot more options than my simple program, and it's able to thread and use password lists in a very effective manner. Hi guys, in a previous video we used a custom script made by me to highlight that capture can work to stop brute forcing, as well as some other solutions that you could implement into your web application in case they had an anti-capture tool. In this video we're going to be looking at Hydra, and basically the basis of this video is going to be staging a brute force attack like we did last time, except from with Hydra in Kali. A really powerful tool with a threading tool, which means it can do multiple things at once, multiple brute force attempts at once. I'm also going to learn obviously the command line options that Hydra provides for us. So first of all, I want to give a little background on what Hydra is. It's officially named THC Hydra. It can support HTTP and HTTPS brute force, and it's from the Hackers Choice Research Group, and that is the THC in THC Hydra. I usually call it Hydra. A lot of people just call it Hydra because it's much easier. It is labelled on the THC website as a very fast network logon cracker. The reason why they use the word network is because it can do other protocols, and this is a very short, such as SSH and FTP. First things first, like most Kali programs, we can just put in -- help, and this will come up with a load of options that we may want. There is also a further help page, that's a shortened down version, and the way to do that is Hydra - and then 1H, and you'll get a full help page that you may want to look at. What I'm going to be covering here is web form post brute forces. In this program though, as we can see here with this example, is that other protocols are accepted, and you can look at that if you wish. There is a GUI version of Hydra. It's in password attacks, online attacks, and Hydra-GTK. If you click that, and this comes up. But for now, we are going to be looking at the command line option version of it, which is simply Hydra. So obviously you have to call Hydra to start the program. So what I'm going to be doing is I'm going to be first statically stating what username and password we want to look for. So that is a -l. It does matter if it's uppercase or lowercase. And we are going to be putting in, for this, admin, and then a lowercase p as well for password, and this is also going to be admin. Now we are aware from the last video that this is valid, so this should work once we have everything that we want in here. So I'm also going to state the host that this is located in, which is 192.168.1.2. So now that we've got the host, that could be the domain as well, we're going to now say HTTP form post. We're trying to use the form in the page to brute force, and it's also a post. And then we are going to enter the post details. So first of all, we need to have the full URL, login.php, and then we need to state the username, and also equals. So if we want to declare where we want to put the user in the post, we simply put it as that, and then we have an and password, and the same again, except from it is in pass. And then we want to put another colon down here. Do note there's a colon there. And we do want to put in something that would be incorrect or wrong, if we got the wrong login, basically. So what we need to do now is put in incorrect login details. So I'm going to now enter some incorrect login details. And now if we just look at the source, it will say here, incorrect login details, check your details, and there is a sad face there. I'm now going to use the term incorrect because I think that no other point of this web application has the term incorrect except from when there is a wrong login. One thing to note that a lot of people don't get is that in code, sometimes the PHP developer checks whether the submit button has been pressed. So if you don't put this in the post that you have in Hydra, then it will not correctly work and you won't be able to use Hydra correctly. A lot of people do not understand that and don't have Hydra working correctly. So what I'm going to put is I'm just going to put it at the start, SMBT1 equals 0. And now what I'm going to do is I'm going to allow that to now go, press enter. And it's found that it's valid. If I change it now to an invalid login name, password rather, it doesn't find any that are valid. So now what I've got is I've got the password set and the users set by a uppercase L and a uppercase P, and they are stated here, users.txt and password.txt. They are what I used in the previous video on the custom brute force I made. So now if I use that, it will come back in a second once it's looked at every single possibility. So here it's found that admin works and test works. So it has now successfully found 2 valid logins via the list that we provided. We could potentially up the threads with the T. So what I've done is I've added the T flag now with 32 tasks. The default is 16, and now it will work in a much faster way than it has. Obviously, the performance depends on your computer, but it has worked faster than it normally would on the default 16. In this video, we have reviewed some command line options from Hydra, so basically the lowercase and uppercase L and P we've seen. We've also looked at we can have different protocols if we necessarily wanted to, and we also saw that you can use HTTP form post, which you have other things available. If you want to see them, you can go into the GUI and see the available attacks. You can use the HTTP get form if it's a get. As well as that, we've started a brute force attack on the average shop script, which has been successful on the static definition we did with the username and password, as well as giving the lists. And we also understood the form validation problem in brute forces, which is basically if the PHP script is looking to see if the submit button was clicked, we need to also include that in the post. So now we're moving on to a new section, which is new tools in the arsenal. Hi guys, we're in a new section now, new tools in the arsenal, which is section 5. And we previously looked into brute forcing, which was section 4. In this section, we'll be introduced to the vulnerability scanner, WEAF. We'll see what open proxies and open redirects are, and we'll also understand what remote command execution and information disclosure is, and we'll talk about tampering data in packets. In this video, we'll be looking at an introduction to vulnerability scanners. We'll learn what they do and why we should use them. We'll also stage an attack with a vulnerability scanner called WEAF, and learn the advantages and disadvantages of vulnerability scanners. WEAF is an open source and free vulnerability scanner created by Andres Riancho, I hope I got that correct, and it was created in late 2006. So there are various other options that we can use for vulnerability scanners. There's Burp Suite, which has a free version but is limited, and they also have a commercial one. Akinetics, which has a commercial one and doesn't have a free version but does have a trial. OWASP Zap, which is free, and we also have WEAF, which is also free. So I think that before I go on to WEAF, I should talk about the advantages and disadvantages of scanning. People talk about that, and I do want to put some points across so that you are made sure about web vulnerability scanning. So first of all, there are advantages. It automates in finding vulnerabilities. It makes it much easier for us to be aware of certain vulnerabilities that may be on a page, and does it in a faster way than we possibly could do humanly. It also crawls pages that wouldn't necessarily be found. It does it in a sort of systematic way that also humans wouldn't do, and it can also fasten the process in application security. So if you've got a deadline and vulnerabilities are found, it fastens the process that you don't need to keep scanning the page and checking manually. It can do that without much help from you. Now there are also disadvantages of scanning. So they are automated scripts. They won't be for your bespoke application, and scanning may not pick up things completely correct all the time with every single vulnerability. That's because, obviously, it's not built specifically for your application. So that is something to take in mind, that even though automated vulnerability scanners are very impressive and they do find a hell of a lot, you will find that also it will be a good idea to do manual checking of vulnerabilities, because the amount of times that a scanner may not find even an XSS while a human can is quite high. Web vulnerability scanners also find false positives quite a lot. Find it in plain text where they find a little pattern and they think maybe that's something that's to do with a vulnerability, or it's not correct in showing you that. This can cost time because you have to check and make sure that that isn't happening if there is quite a lot of these false positives, and that's something to take in mind with web vulnerability scanning. As well as that, the last point I want to bring up is that no skill is required, and what I mean by that is, it's quite easy to enter a target's name and click scan and then paste all of the vulnerabilities that the scanner's found. You should look at the actual vulnerabilities that are within the scanner. Sometimes it does bring up false positives, even though it looks like it can't possibly not be that vulnerability. You should always check, because sometimes computer programs aren't always right. So first of all, you can find WEAF in Kali Linux web applications, web vulnerability scanners, and it is here, next to Vega. You'll be confronted with a GUI that looks like this. I've already entered the target in here, which is HTTP 192.168.1.2, and also the folder path. What we've also got on the front page is profiles. Profiles allow us to custom build what sort of scan we want to do of this web application, and I have chosen the full audit profile. We can also edit this profile by going into here and ticking boxes. And we can also learn about the different features that it has by just clicking on the text, and it will highlight it, and we can read what it is in the right of the window. For now, we just want the defaults on. We can say start scan here, and it will begin to scan. And if we go down here, we can see that there's various information that will tell us about how the scanning is going on. And the information it's giving is basically what the crawling is doing at this current time, what the audit is currently doing at this time, and then we have a log showing what it's found while it's scanning. The HTTP speed is how many requests it's doing per minute, and this is a simple graph telling us the debug information it's giving, as well as the information, as well as the vulnerabilities that it's found. As well as notice, there is an info sort of color-coded text, basically, so red is vulnerability, and blue is information. Now, what I would do at this time, if you are scanning a web application, is to leave it with itself, because it may take some time to fully audit. Depending on how many pages you have, can depend on how long it takes. So if we go to the exploit tab, which is available here, we can see that there'll be a load of exploits potentially in this long drop down. Most important ones with crosses like this, and if you highlight on them, the exploits which you can drag and hit will exploit, but I do say that it actually is better if you do it outside of WEAF and learn about the vulnerability within WEAF. So if we go to result, we can see there's a lot of knowledge base within our scan that I've just done quickly, and we can see there's an SQLI already. If we go into that and just highlight into the tree, we can see that it'll allow us to see some information about it. So we got SQL injection and then MySQL database was found. So it looked and it found that the order ID basically is SQL injectable. And then it gives us some raw, what it done in the request and the headers that it gave within it. And then the response that it got, as we can see here, it wasn't ready for that. It also has an encode and decode feature that we can have here, which is fairly good because it also has a manual HTTP request option for you as well, which you can send. And we can also look at the layout of the site almost by using the results URLs tab here, and we can see that this is the host and it goes to these are folders. So we've got work here, course, and then it goes to pages, then another folder. And this is quite a good thing to look if you got the crawler on and you're not fully sure of various pages and they don't have robots.txt or sitemaps. This is a fairly good, surprising feature of WEAF I thought they didn't have. One thing that I would like to know about what I said in the disadvantages is that WEAF thinks it's found US social security number within my CSS. This is the sort of stuff that's a problem with vulnerability scanners at the moment, and I do think that people that are looking at vulnerability scanners and finding them attractive should use them, but also don't use them and not do manual penetration tests as well. That is a thing that should be taken to note. So in this video we've understood the basics of WEAF. It has the exploits, you can look at the various maps of it, you've got the logs, and you've also got what you can see the specifics of what it's found in the results. We've learnt about advantages and disadvantages that may come from automated scanning, and we've also staged the scan to find various vulnerabilities. It found the SQLI. In the next video we'll be looking at open redirects and open proxies. Hi guys, so in the previous video we looked at vulnerability scanners, WEAF, how good they can be. They can find vulnerabilities very fast and allow us to find a various amount of vulnerabilities in a short amount of time. So in this video we're going to be looking at open redirects and open proxies. The reason why these I put together is because they're relatively similar. Open proxies doesn't happen as often as open redirects, but I still think it does require a highlight from me, because sometimes web application developers don't fully understand that functionality like it can be exploited. So in this video, we're going to be learning what open redirects and open proxies are. We're going to be seeing how they can affect a user and how they can be avoided. So open redirects are usually used for tracking or an easy way to administrate navigation around a large-scale site. I see this quite often with big sites because it becomes easier to initiate a function to just simply check the posts, and it seems to be centralized and just much easier for them to do that. It is also usually used when redirecting users to third-party sites. And with both of these, open redirects and open proxies, user interaction is not required. And first of all, what open redirects is basically a GET request is provided. So we have a URL, let's say in a GET parameter on a site, and it will basically state a page. So it could be a third-party website, or it could be trying to redirect to another part of the site, be it another subdomain of the site. But what an open redirect means is that you can redirect it to a third-party site that it normally wouldn't be. So with redirecting third-party sites, normally you would have a whitelist, but sometimes they don't properly validate, and so the whitelist doesn't become effective because the developers haven't properly validated the root domain, which is the sort of pinnacle of this exploit, that the root domain of these parameters aren't validated properly. With open redirects, it can be used in phishing attacks or social engineering to get a user's system or to get their information. With open proxies, it's a similar idea, but with this, in the parameter, it gives you a file, you download it, and it looks like it's from the site originally downloaded from. This is usually found in image sites or file hosts, and what I've put as an example is it can be used as a gateway for downloading malware to a trusted host. So let's say Microsoft, a fairly trusted company, if you found an open proxy within there, most people would download from Microsoft, and so it's a very beneficial exploit to find for a person who's wishing to give a social engineering sort of side of downloading malware to it for a user. So what I've done here is I've basically set up a validation procedure that is incorrect. It will basically check for the local host. Conf is where the host is. If you want to see, it's here. So it's basically checking for a string in the URL get parameter, which is localhost. If it is in there, then it will go to the location, it will redirect, otherwise it will not redirect. As we can see with the inc redirect.php, the URL has localhost included, so it should go to the google.com. As we can see, it's gone to localhost.google.com. Localhost.google.com doesn't exist, so it's unable to find it. And what this code does is it basically checks with regex, which I advise, so that now if I put this in, it will simply find it as google.com because it's gone through and filtered and validated and found the root domain. So if I press enter now, it will find that it's google.com, yeah, invalid host, and it's found the root domain google.com, which means that it's not localhost. So what I've done is I've edited the directory traversal file to make it look like an open proxy vulnerability. Basically what it does here is it checks if HTTP is included in the string. If it isn't, then we won't do anything. Otherwise, we get a file, got contents, and we give it to the user. What we can do here is we can simply get it to download it from somewhere, and then we can download it from the host that we've used, in this case localhost. So what I've done here is I've basically got get.php, and we're going to be basically downloading from packed publisher. But what is going to happen is it's going to look like it's downloaded from localhost. As we can see here, it says from localhost. Other browsers would use the domain localhost as well, and it looks like it's originated from localhost. Basically what we would do is we would, like the redirect.php, we would regex the get parameter to validate whether it is got the root domain or if it's part of a whitelist, which we would use the array like the directory traversal, and we would basically check whether it is correct or not. If it isn't, then we give it an error message, otherwise we can download from there. So in this video we've understood what open proxies and open redirects are. They're a way of getting a third-party website to do something like the functionality of downloading or redirecting. And we've also discussed how we can resolve open proxies and open redirects. Essentially, we just need to validate and make sure that the get post or whatever in the parameter needs to check for the root domain to make sure that it's a whitelist within the array or database of third-party websites that we trust, or it's part of our own servers or domains that we have, or our own domain that we have currently. So the next video will be about remote command execution, or as a lot of people call RCE. Hi guys, in the previous video we looked at open redirects and open proxies and how we can use them to get users to potentially redirect to a third-party site, or we could get them to download something because they trust someone else. In this video we're going to be looking at remote command execution. We're going to be looking at what remote command execution is, what the potential effects of remote command execution are, and how we can avoid remote command execution. So first of all, remote command execution allows you to execute remote commands, basically. It's a fairly simple name. Simply, you're able to execute commands that normally you would do on a server, but remotely, so within the web application. Usually performed by executing 2 commands on one line, and I'll get into that in a little bit later because it'll make more sense. To me, it's very dangerous. It has potential to have full control over the server. It can lead to privilege escalation attacks if it's the web server process that you are within, if it has its own user or the process is restricted. So what I've done is I've got a little scenario here now, is that I think it would be ideal for me to show that an attacker could find an SQL injection that we have within our average shop script and can also use common page names to find pages that necessarily wouldn't be authorized. And what I mean by that is it wouldn't check if you're logged in, basically. So first of all, I'm going to use something called Uniscan, and that's available in web applications, web vulnerability scanners, and it's next to WEAF, it's Uniscan GUI. And what I'm basically going to be first doing is I'm going to be checking for directories within the directory work course, and it will, in a few seconds, find there is admin available. There we go, it has the course admin. So what we could do now is we could do a file check in which we check whether in that folder there are file names that we may find interesting. So what I'm going to do now is I'm going to check for some files, and I'm going to be adding the admin folder, as we're aware because we checked the directory. We're going to start that scan, and it's going to start scanning and looking for certain names that are common within web applications. And here we can see we've found 2 here already, cp.php and index.php, and I'm going to enter them into the Iceweasel browser and see what comes up. So what we've got here is it hasn't got a get request C, which we should be adding here, and also it's printed out ping. So basically this could be a remote command execution. I already know it is, and basically what we could potentially put here is we could test it by putting google.com, and it has come back with a correct ping. And now what we can do is we can add something a little bit different. Basically, as we all know, get parameters and post parameters, when you add an and into the URL, it will look for the next parameter such as D. But if we encode it, we can include it into the string such as google.com. And what CMD has, as the web server is located in Windows, is that the and function allows you to have more than one command, and the encoded version of and in a URL is %26, and then what I'm going to do is I'm simply going to choose who am I. And as you can see, it's added on the end jack, which is the user is currently running this process. I'm going to go into the code to sort of show you how that sort of worked. So first of all, in the index page, there is a form in the admin which allows you to post a domain or an IP to cp.php, and because not necessarily it's not included anywhere, there isn't a form action here, web application developers usually think that, it's hidden. And so cp.php doesn't have an authorization check. It gets a get and it checks it. Basically, it adds a ping. It wants to ping this, so it does a system execute. And as we can see here, what we've basically done is we've added to this and then done a who am I here, which has allowed us to execute more than one command. So how can we change this so that this doesn't happen? Well, first we can make sure that we can authorize so that this doesn't have direct access to it, or that it isn't included in one page, it's included on the index page. Also, what we can do so that other commands can't be executed is we can validate domain using a regex to make sure that it's only a domain or an IP that's included. We can do this with simple regex expressions, or we could even just use a function that's available online. I'm sure there are some available, but we would first check, without doing the system, we would first check that it doesn't have any special characters. We would check if it contains an alphabet, numerical, or a period, so that an AND code would not appear within the domain variable. So when it comes down to it, it is simply checking for the user input. Even though it's admin, you should always check even in the admin, because potentially you could have someone who has unauthorized access, be it someone was infected or someone's infiltrated the system in another way. So in this video, we've discovered what remote command execution is, and we've also understood how fatal it can be to a system. Using regular names like cp.php admin as the folder sort of comes toward just common practices not to do, but we should also validate that what is included in the user input, even if we are in the admin area. It doesn't matter whatsoever. And also making sure that we do have authorized access everywhere, that we don't have pages like cp.php. And as well as that, we're also making sure that it's validated and it includes only a domain or an IP, or whatever our functionality of the web application is, that it only includes the validated data that we have for that particular command. In the next video, we're going to be looking a little bit into information disclosure. Hi guys, in the previous video we looked at remote command execution and how you should always validate user input even if it's in the administrative area. So in this video we're going to be looking at information disclosure. We're going to be seeing why information disclosure can lead to big problems. We're also going to see common information disclosure mistakes, and we're also going to be talking about my view on robots.txt. If we're not sure what a server fingerprint is, we did it in an earlier video. If you use the curl command curl and then uppercase I, you can receive the head data, so we get the web server technology, which is Apache and its version number, the web technology number, PHP and its version, as well as the operating system. That is what I mean by server fingerprint, and it allows an attacker to get a file structure that may be needed for another attack. So with SQL injection, where we had SQLMap, we had to give it a full path, and if we don't know the operating system, it has to guess, and so we can give the attacker less information by just not providing valid operating system information, web server information, as well as the web technology information that we have. If we give the attacker the information, they're also they could possibly exploit it itself. OpenSSL, a version of it is vulnerable to Heartbleed. That is shown in some fingerprints sometimes. Also, operating systems have different syntax with different technologies, so it's much easier not to provide the attacker any more ammo than they actually have. Now, I want to talk about robots.txt because a lot of people use robots.txt to disallow the admin folder, and I actually disagree with this. I think if an attacker finds an admin page, they should be unauthorized anyway. Disallowing it in robots gives them one step further into finding a vulnerability, and they've found some information. It can also give information into the structure of the site, which isn't always the best, such as an includes file, which may not necessarily have the necessary validation checks if a user visits that page directly, which I'll go on to in a bit. So I think robots.txt, you should definitely, if you're going to use robots.txt, do not show things like disallow and then the admin folder. Client-side comments as well. This one's a fairly obvious one. Do not use client-side comments for information like server variables or server structure, IPs. It's still quite a common thing that people do that. It shouldn't be done. Only use client-side comments for design issues or comments on it. So we're now going to go into the average subscript and look at some information disclosure examples. If you remember, there's an inc folder available, and this is quite a common folder name. As in the previous video where there was admin, there's also inc. Uniscan can find this, and if we go there, there is no index.php because we don't really use inc. It's usually just included. And if we visit head.php, we get these require once. This gives them more information than they should because it allows them to see the full web server path, which we don't want them to see because of SQLMap and other applications that may require a full web server path. As well as that, it tells us that it requires a name, and this can be useful if we go back to the index, which provides style and shows that we're putting in black, because we can now understand that this may be vulnerable to a local file inclusion or even a remote file inclusion. As we can see also, this is giving us information, as I've said before, the OpenSSL information. We do not want to give all of this information away. A lot of servers do, and a lot of companies are okay with that. I personally think you should give as less information as possible. Also, when logging in, you should always not specify what was incorrect. You should just say incorrect login details. We can just basically give them a very vague answer that both of these fields or all of these fields, depending on how many you have, are incorrect. If we just give it a blank file, no information needed at all, we'll see that no information comes up and then inc is just a blank page. This is what we want. This is ideal. As well as that 404s, any error page, you might want to do custom error pages or custom, just to have all error pages given to a custom page saying error, because it gives the full path. You can just set you do not wish to show the full information, but as well as that, we know that this is quite often used in XAMPP, and we can fingerprint that XAMPP is used, as well as the icon, which is commonly used. So in this video, we've learnt about various information disclosure methods and how important they are. Sometimes they can give a lot more information to the attacker, which could mean that they could potentially do SQLMap, they could do an SQL injection, or they could do a local file inclusion, or another vulnerability, depending on what they've found. So it's always best to give the attacker so little information, or anyone, in fact. In the next video, we'll be tampering data and packets to change values and make the web application react differently than it should. Hi guys, in the previous video we looked at information disclosure and how important that can be to us. In this video we're going to be tampering data in packets, and basically we're going to be using Paros to view requests and change values, and we're also going to have an example of how this can affect an application. In our instance it's going to be average shop script. So first, to get to Paros we need to go to Applications, Kali Linux, Web Applications, and we will want to go to Web Application Proxies, and there's Paros. So once that's loaded, you may want to first check in your options that your local proxy is set to these settings. If they are, or if they're not, it doesn't matter, but these settings have to be configured towards your browser. You're going to be putting in the proxy settings, these settings you have within your Paros application. So in my proxy settings there is localhost and 8080 in Iceweasel as the port. Once we've done that, we're able to communicate effectively with the browser. If I just enter that, it'll be able to view the average shop script. But as well as that, what's happened is that on the Paros side of things, we've been able to view the site structure. So we've got work, then get course, and this is the index, but it doesn't have it available. One thing that we can start off before we even start tampering data is we can actually analyze this by going to the spider option and start. This will begin to get a load of pages up for us, and we'll be able to analyze these pages and maybe check to change the parameters. And yet again, what this is showing is that crawling is a really good idea if you're going to be analyzing a website, because automated crawling allows us to look at various parts of the website without doing much ourselves. But this is actually a really good way to manually check things. Even though the crawling side is automated, we can manually check things by tampering the data, as we're doing in Paros right now. So what we could do is we could trap some data. So first of all, what we could do is For example, if there was client-side code that was sending requests to another subdomain of the website, such as analytics or something, then we would be able to view this and tamper with it. But for example, I'm going to be using a sort of theoretical scenario right now. I'm going to be choosing the login and the style for this. So first of all, what we need to do is go on trap, then we need to tick trap request. Then what we're going to do is we're going to go down and we're going to choose login. And as we can see, it's sort of hanging, it's not loading properly. If we go back to Paros, we can now see that in the trap section there is this window showing us some information. Now we can change most of this information if we wished. So we could change the cookie value if we wanted to act as someone else, as well as executing a request. So in my example, I'm just going to be changing this to PHP, and then I'm just going to add a letter D. The main thing is that we could add a cookie and send a request by tampering it, by if we were submitting a button, or there was the web application had client side submitting, we could tamper with that and look at what's being sent and what should we edit to see what happens. As you can see, it's come up with PHPD because that doesn't exist, and we can see there's an error and the experimentation has gone well. We are already aware of this bug that we've already made before, but it's theoretical. If you have a client-side sort of Java script, sort of Ajax requests, or you've got a form submitting and there's various encoding techniques, although you could check on a browser, it's much easier to look through Paros, as you can resend requests and spider pages, and it's just a much more rounded application for such things. We've also got within it some tools for us if we're going to be using the sending requests. So URL encode is fairly important. As I did in the last few videos, the and was fairly important. We're going to need that. As well as that, there's URL decode if we really needed to. That is available in the tools encoder/hash. So in this video, we've successfully changed the value by interception with Paros. And we've also understood how Paros can be beneficial in manual scanning. It allows us to view all the pages and see different parameters, and much easier than automated vulnerability scanners. It gives us the freedom of being able to change values, but it also gives us the ability of crawling, which allows us to see all the pages that are available from the crawler's perspective. So we're going to be in the next section in the next video, and it's going to be called Silent Manipulation with CSRF. Hi guys, in the previous section we looked at vulnerability scanners and also vulnerabilities such as open redirects and open proxies, tampering data in packets and information disclosure. In this section we'll take a look at a vulnerability which is CSRF. It stands for Cross-Site Request Forgery, and the section is Silent Manipulation with CSRF. In this section we'll see what CSRF is. We'll use a CSRF tester tool and see what token and same origin policy is. In this video, we'll talk about CSRF, understand the concept of CSRF, its consequences, and an example. So with this vulnerability, a site is able to sort of impersonate us and interact with this website as if it was us. There's many ways in doing this, and the reason it can do this is because we are logged into this, and it can iframe or it can submit a form which necessarily could submit data on our behalf without us even knowing. So I'm just going to show a little example of this. I've got an iframe set here and it's going to just load up. And this could be on any website. This website could have an iframe anywhere. And if we go back here and go to ID 1, we can see now that the CSRF has actually entered some data here. So we've got the review has been set as well as the description. And the way this works is it sends a simple GET request. So here we can see order ID 1, the submit button for the form, the stars. This is a simple GET request that it's provided, and it's simply just put it in an iframe. And because we're logged in and it's an iframe, and there's no sort of defense against this sort of attack, the web server has just thought, well, they've just inputted some data here, obviously, and it's impersonated us and submitted this data. So I've manipulated the script right now so it now does post as most forms would commonly, and so the post example is a little bit different with CSRF. It's a little bit more involved. Obviously you can't just send an iframe, so let's just show that. So first of all, we've got the source as x2 and we're on x3, so let's have a little look at x2. Okay, so I've changed this script a little bit in x2 so that it's much easier and we can see this step by step. So first of all, on the load, it calls loaded, and this will basically send the form. I've obviously commented it out so we can see it in a better way. And we're basically sending the form also completed, so we've got the values set already for us. So if I just comment out and show it in action, if we let x2 load now, we can see that you have been rated. This would obviously be in an iframe, so we could just simply let that run in the background. The form is auto completed, so it's in the post method, and it's successfully impersonated us. I'm using impersonated in quotations because obviously it's not necessarily correct, but correctly brought some data into the review section. And one of the problems this could give for a user is if they're logged into a shopping site or a financial site such as your bank account. Someone who, if you view a website that you commonly view and an attacker takes place of that and he knows or she knows a cross-site request forgery vulnerability in a website, they can use that and potentially order something and change the address to have it shipped somewhere else, or they could move money to another bank account. So in this video we've understood what cross-site request forgery is, and we've also discussed how CSRF can also affect a user in different ways. In the next video we'll be looking at CSRF tester tool and also mine. Hi guys, in the previous video we looked at the concept of CSRF and what it actually is. In this video we're going to be looking at some tools on how to sort of automate that process. So first of all, we're going to be using OWASP's tool. So first of all, as I've said, we're going to be using theirs. We're also going to be having a look at something I've developed because I thought that there was a distinct missing part, I thought, in tools features, so I've decided to add my own. We're also going to be using web proxies to help generate these CSRF tests, because what these tools do is they basically allow you to submit data and then they replicate this in such a way to test if that actually works. I'm also going to be obviously solidifying our understanding of cross-site request forgery because of doing these test tools. We're understanding it better in a more practical way. So first of all, the first tool is OWASP's CSRF tester tool. It is built in Java, and really it's used for Windows because to run it you have a run.batch file, which is interesting and I thought wasn't exactly great for Linux users. There isn't a lot of documentation on it. It doesn't help whatsoever in that instance. So although it is simple and effective, users may find it quite hard if they're new to the tool. It also has problems with localhost. It doesn't like using that in the proxy listener it uses. My tool and the tool OWASP does but effectively the same thing, except from mine's built in Python. Pinata is something that I've seen but is very old, not very well documented whatsoever, and the post could be simplified. This is why I created the new tool, because there wasn't really a Kali Linux sort of alternative at all. Pinata was sort of one of them things that hadn't been developed in a while, and I thought that I should potentially just develop my own and help people. And so my tester tool is built in Python. It's built as an alternative. 3 arguments are needed, and it's a simple form submit template that's created. There's no bells or whistles with it. It's just very easy to use. So we're going to be covering 2 of these, mine and OWASP's. I don't think it's particularly appropriate to cover this program. I think it's kind of old and it's past its time, so I've decided against showing that. So you'll be presented with a run.batch file which will open up a command prompt window and open up within it the web scale proxy listener for OWASP CSRF tester tool. And then you will have to set your browser, depending on what you have, to this specific IP and port, so localhost and 8008. So I'm just going to set that there and click OK. So now, because we've loaded the page up and we're about to enter the data that we want to replicate potentially on another site, we simply have to click record, and then what we're going to do is we're just going to enter some sample data and click rate, and this will allow it to view what we want to actually enter in, the data that needs to be manipulated and impersonated. So if we show the command prompt, we can see it's got a response. We can stop recording now. This is what we want to use. This request, it has the parameters recorded here. We're just simply going to use that. That is for the next video. I've already implemented it, but I've disabled it. And what we're going to do is we're simply going to generate HTML. You're also available to do different types. With my application, you simply have forms. That's just the way I do. So once you click generate HTML, you can choose a folder and save it in there, and it will auto load up the actual web page to show you that it's worked. And there we see we've got a second ABBCC. It's correctly worked, and we can successfully say that this tester tool has worked and there is cross-site request forgery. So very easy, very simple, and I commend the OWASP developer team for developing that tool. Okay, so with Kali Linux and my tool, you should first open up Paros. We're going to be using this to get the data, so we need to go to Web Application Proxies, and you'll find Paros there. Let that load up, and we're basically doing it in a more manual way than the CSRF tester tool. I didn't combine the two together. So first, have a little look at what your local proxy is set as. I've set this as 8008, the same as the CSRF tester tool, the web scarab. I'm not sure if it's defaulted at 8080, but you may want to change that. If you want to go to Iceweasel now, and you need to change the network proxies to allow you to see the data being submitted. So we're just going to set this as 8008. So what I've done is I've loaded up the average subscript after editing the proxy settings, and as we can see, we've got some entries now added to here. We don't need to worry about these at all. We want to look at 192.168.1.5, which is mine. I'm going to the subfolders now, we can see here, and as we can see, it gets the requests that we provide it, and it's sort of a similar idea of first getting the data that is provided and replicating that and seeing if we can impersonate the person that's logged in. First of all, I'm going to log in. Now that I've logged in, I'm just going to simply, like I did last time, enter some example data so that we can see what we can add, and I'm going to click rate. And obviously we've rated it, it's successful. If we can see here, we've sent a post request from order, the post form. We can see now that we have some data that we might want to add. As I said in the CSRF, this is going to be much clearer in the next video, so we don't need to worry about this parameter whatsoever right now. But we're going to be using this information to replicate what we did in CSRF tester tool. So first of all, what we need to do in this subfolder is see that main py is there. We're just going to look at the help file to see what we've got to do. So we've got to set a URL, some post data, and whether or not it's get or post. Most CSRF are post, so I'm going to be talking about post data for this example. So first of all, obviously we need to set python main.py, and then set the URL, which we already know is HTTP, and then the IP that I have currently set for the web server. And then because it's a GET request, I'm going to add the ID here, or otherwise it won't work. And now we need to put the data that we have available to us in Paros. So we're just going to replicate this by adding this. And of course, this is a post. And I'm going to put this in all capitals. You can put it in lowercase or uppercase. And now it's wrote a example.html. So we see there it's done it. If I just echo that out, we can see now that it's relatively similar to the first video that we created. It's just entered all the values I've provided, allowing you to successfully replicate the data. So now if we go into that folder and open example.html with iSweetle browser, we can see it loads up there and then it rates it, as we can see here, much like the CSRF tester tool by OWASP. So in this video we've learned about the different tools we can use for cross-site request forgery, and we've also solidified our knowledge on cross-site request forgery. In the next video we'll be looking at tokens and same origin policy. Hey guys, previously we looked at tools and how they can help us in replicating and seeing if these web applications are indeed vulnerable to cross-site request forgery. In this video we're going to be looking at tokens and same origin policy, and we're going to be basically looking at the defense side of cross-site request forgery. How can we stop this from happening? So we have in this video how tokens can help us in defending cross-site request forgery. And also we need to discuss how we can't just use tokens. Tokens aren't the answer to cross-site request forgery. We need to use more than just tokens, another line of defense. And we're going to be overviewing on same origin policy and how that helps against CSRF. So in JavaScript, it has the same origin policy. There's more than one. In this instance, I'm going to be talking about same origin policy because it helps protect against CSRF attacks. It restricts one application to interact with another. So here I've given a nice little table and a Wikipedia reference from the page of this image, but what I'm saying is that JavaScript helps us against CSRF attacks because the tokens that I'm about to show, that defense mechanism, the tokens can't be read because of this same origin policy. Now tokens are hard to define in some ways. Some people find it hard to understand, and I hope that I define this in a good way so people do understand. Once a page is loaded, you are given a random token, which is within your session. It is given as a session on that page. If the third party tries to stage a CSRF attack, they need your token session to get the correct functionality. And the way you do this is you check the token if you're doing something such as we'll be doing in a second, the review. The review functionality checks that you have the correct token for that session, and if you don't, then you're not allowed in. Capture is another line of defense. It isn't exactly liked by a lot of users, which means not a lot of web applications do it, but capture is another defense against this because obviously it can't fill out the capture for the functionality. Referrer headers are another line of defense. Shouldn't be the only and shouldn't be provided as empirical evidence that this is a CSRF attack, but should be taken under consideration. All requests provided a referrer that is empty should be counted suspicious though. It shouldn't be processed. And coming back to CSRF and the same origin policy, if you have an XSS vulnerability, then all of them things are thrown out the door because XSS can provide a sufficient vector for an attack to read the tokens. Tokens are a great defense, but because of this, if you have an XSS vulnerability, other measures should be put in place just in case. So I'm just going to go through the code and sort of help solidify this token idea that we have against cross-site request forgery. So first of all, the form submission is asking for a token, and then it's provided here as a variable posted token. And then as we can see by me highlighting that we have an if, which asks if it is equal to the session token that we have. And this logic allows us to say, if for example someone attempted a CSRF attack, they would need our unique token to successfully insert a review, because otherwise they need to know our session because it's already been set within a web application, which is in token.php, which I should show. If we go down to order.php, we can see that generate function is used, and this function basically returns a session declaration with base 64 and a function for random pseudo bytes, which is 16 bytes. And this is a random sort of trying to create the most random value possible so that someone can't guess if that value is correct. And this is one of the most secure ways I've seen online so far. Tutorials online showing SHA-1 and MD5. I don't think you should use them. I think you should use this. And with that token, no one can possibly guess it. And so because it's set as your session, there's no possible way of a CSRF attack unless cross-site scripting is involved, because they can't guess that token. And there is some logic to this. If you generate a token before the check, obviously there's going to be a different token from what you've set in your session, and so the user submitting a valid request won't happen. So if I put this function up top here, it will basically generate a new token, which means that this will see it as incorrect because our session token has been replaced. So if I now try to review, we can see that it's incorrect. I've truncated the table beforehand, so that's why them reviews have been removed, but no reviews have been added, and this is simply because of the logic of this web application. That's something important that you've got to take into account here. So if I now remove that, we can now sort of understand that when we send a request, because of how the logic of this works, a user with a real session, the person that's actually using the web application, will have no problem because the check is used here and then a new session is submitted here. And we can see that if a third party tries, they have to guess random value, which they couldn't possibly do. So I've just opened up the CSRF OWASP tester tool, and as we can see, that also didn't work. This is because of the tokens. As I've said beforehand, they work correctly, and it's great that they do. So in this video, we've learned about defense towards CSRF. We've looked at tokens and how, if we generate them first, then it's not going to work. We need to have them last and also have a check to see if they have the correct token provided from the session we created. And we've also understood JavaScript's same origin policy, and now how that helps us in the token method we provided here. It's basically allowing us to not have the token read from the source. So in this section, we've basically overviewed CSRF. We've looked at what it is. We have looked at different tools, and we've also learned about the defenses. In the next section, we'll be looking at extra measures for the shop, which is the last section. Hi guys, in the previous section we looked at cross-site request forgery and how it can affect a user and how we can prevent that. In this section, extra measures for the shop, we'll take a look at OWASP Zap. We'll see what two-factor authentication is, we'll talk about weak passwords and phishing, clickjacking, and finally wind up our course. In this particular video, OWASP Zap will talk about various features of OWASP Zap, like plug and hack, fuzzing, and how we can scan for vulnerabilities using OWASP Zap. OWASP Zap is another vulnerability scanner, but it has some interesting features that I think we should look at. So first things first, you can find OWASP Zap by going to the web applications and web application scanners. You can find it there, or you can simply type it in command line, such as this. Now it does take a little bit to run, don't worry, if you've just clicked it in the menu, it does take a little while to set up because of the different things it's running. As you can see, you can probably see it has Paros also running alongside with it to do certain capabilities. One of the things that I'm first going to look at here is the plug and hack option that we have available to us in Kali, and what you can do is to configure it, you can simply just click plug and hack, it will go to it, click setup and say I understand and enable. I already have the add-on installed. As well as that, if that isn't working correctly, you can also in your preferences change the network connection to localhost to 8080 and it should be okay, and then it'll be able to read what you're doing on your browser. So right now we can see that nothing's here at all, and if we go to the alerts, which is fairly important if we want to know about vulnerabilities in this program, so the alert is there, and if we go down and just refresh the page and go back to OWASP, we can see now it's loaded 4-5 alerts that it has here. So we have cross-domain JavaScript source inclusion, so I'm basically having a third-party JavaScript, so the Google API, I believe that is, yeah. Also we have other things like content type and X-frame options. If we just go ahead and use the spider option here, down below, and we've already got it set as 192.168.1.3 because we're in that section. If we go over here, we'll obviously be scanning on the Google API site. We don't want that, we want to go on this host, so we highlight that, and then we'll click play, and it will start scanning in the current folders it already knows are available, so it will start to get other pieces as well. So the spider is done, and much like WEAF, we basically have a request and response that we can actually look at. So if we go back now and just enter login and put in sort of generic SQL error, we don't know what's happened here because of, like I said in previous videos, elements have gone in the way, but we do know that there's incorrect login details. If we go over to the OWASP Zap and go on here, we'll see the course login. We can see it actually has it available here for us. It hasn't picked it up yet that it's a MySQL injection, but it has noted there is an error because sometimes some of these errors can be caused in different ways other than SQL injection, so that is why it's currently an application error disclosure. But it's really a good idea that I like from OWASP Zap that there's a thing called plug and hack where you can basically test out various things. It will log out everything that you have available to you, and you're able to check back and look at the alerts that it has available to you in this section. So what we can do is we can also fuzz. Fuzzing is basically where we're just trying everything that's possible to see if it comes back with an error. So what you need to do for fuzzing is basically highlight where we want to go for fuzzing and click fuzz in the requests. And then we're going to choose SQL injection for this, and I'm going to highlight SQL injection. I'm going to fuzz, and it'll basically try different possibilities that it has available to it within that fuzzing table that it has. But really what we want to see is the response that it comes back with. So we know that it is an SQL injection here. So if we look at a response, it's okay, it's 200 okay, but if we go down in the source code, we can see that it does have SQL injection there. And that's good if it's not working in one way and you're not sure how to do it another. You can just send a fuzzing and see what comes back, successful or failed. What I'm going to do now is I'm just going to simply just do an attack, which does take some time because it does various types of attacks on various inputs. So if we just click attack, what it will do is it will spider, it will do all of this for us automatically, and sometimes that isn't great and sometimes that is. That's why plug and hack and fuzzing is a good idea, and why sometimes automated attack sometimes works. So right now we have 8 alerts. If we just click attack and come back once that's done, we'll see what results have changed. So I've come back, it's about 15-20 minutes now since I started the scan. Obviously it'd be different depending on the size of the web application, and it's found a lot more than it would normally. It's found a lot more. It's got 13 now instead of 9. Found various exploits available to us, and we can use them. And also if we go into one, much like WEAF, you can have a look in the payload it provides, and it also gives you a little bit of information. The description of a cross-site scripting attack is available there. In this video we've understood how to set up plug and hack in OWASP Zap. We configured it with a browser, changing the proxy so that it could listen properly, and this is great if we want to do a I call it semi-manual sort of scan of a web application, because you're basically getting alerts from the program from what you're interacting with, but you can also test it by yourself manually without having to use scripts that are pre-made for general applications. So you can do it in your own way but still get alerts, which I think is a fairly interesting concept. We also reviewed some of the OWASP Zap features like plug and hack, like fuzzing, and also like spidering. There is a large amount of features in OWASP Zap that can find vulnerabilities within a web application. In the next video we'll be looking at two-factor authentication and how that can help users. Hi guys, in the previous video we looked at OWASP Zap and its features like spider, fuzzer, plug and hack, and in this video we're going to be looking at two-factor authentication. Specifically we're going to look at what two-factor authentication is. I'm going to be doing a practical side of that. You'll probably understand once I've shown you the practical side of two-factor authentication. You've probably seen it before. And then we're going to look at how it can be implemented, used within a web application, how you can use it, and different ideas and implementation, and why also it can be important to users, to you, and general security. So what I've got here is I've made a simple login. It doesn't actually log in, it's just to show an example of what two-factor authentication is, because you've probably seen it before. And the sort of scenario here is that an attacker's, attacked and found, the admin password, but doesn't have any other exploits to get into the system or muck around with any of the parts of the website. They're only able to get the administrative password. So now that they've found the login, because there's a default folder and a default name login.php, if they use a correct login, so I'm just going to put in the password, it doesn't matter what I put in, and then it comes up here, and this is what two-factor authentication is. It's another part of authentication, be it sending a message via SMS, sending a phone call, or doing it via an application, an app, a phone app, that's also a thing. And then once they've received that second part of authentication, they have to feed it back through the web application as we see here, and then if it's correct, they can log in because the administrator has already set what number it is. So with implementation, you've got to think of, do you want to start your own service, which could cost a lot, or do you want to use a third party? And there are some really great third party services available for two-factor authentication. Then you've got to think, I always think you've got to have an efficient API. There's no other real way that you should do it. Storing details of the email with a phone or their ID, depending on what you're doing, what you're sending. It could be just a text message, a phone call, or within a phone app. And then you've also got to send an API call saying that the person wants to log in first of all, and they've done the correct password. That will initiate the phone call or SMS to the person's set phone. Necessarily, you would first have to register the person's phone number. As we see here, store details correlating email. We would need to do that first before even starting sending API calls from login. Once the API has sent the SMS or phone call, then it will enter in the code and the API will tell us if it is correct or not. That is how it would be implemented in my way, and I think a lot of third-party services use it in this way. This can be important to a user because that two-step authentication where they have to have another part of their identity, another part of that person, it becomes much harder to hack into things that necessarily would be much easier a few years ago because they didn't have two-factor authentication. It means you need another level of someone else's identity to take that login process away. And that's a really good way of making sure, not for definite, but a reasonable assumption that the person who logs in is who they say they are. And that's why I really like two-factor authentication, and I think you should at least implement it in admin panels. In this video, we've understood two-factor authentication and what it is, and why two-factor authentication should be used. It's great for security. It helps in making sure that you're for definite the person you say you are, and it can be very easy to implement. Third-party services have tried really hard to make it easier for people to implement two-factor authentication. In the next video, we'll be looking at weak passwords and phishing. Hi guys, in the previous video we looked at two-factor authentication and how important that can be to verify that someone is who they say they are. In this video we're going to be looking at weak passwords and phishing. So we're going to be looking at how we can help users in creating a secure password, but as well as keeping it usable. It's that argument between usability and security that's quite pinnacle to a lot of discussions in security. You've got to have it so that the user can do things and they don't have to type in 40 characters every time to enter their password, but they still have a measure of security to keep them safe. And that is a real hard thing to do. As well as that, we're going to be looking at phishing prevention and how we can sort of try and attempt to help users in not being phished. So first, we want to make sure that they don't enter a password or username that is a really short length. That is basically what we want with weak passwords. We want to make sure that they don't have weak passwords and that we have a secure system. Now, the numbering that people have is very different, and I'm a little bit disappointed that some banks have a small number as a minimum. I usually go for 10. I think that's acceptable, although, different cases means different numbers in some cases. What I've got is I'm going to put in AS and AS, and if I register, it now says username must be greater than 6 and less than 40. I think 40 is a reasonable amount. If you go higher than 40, a lot of people think that, the amount of numbers is great, but if you go to more than 40, it can lead to denial of service because of the amount of characters that you have. You could potentially use a denial of service because they accept that amount of characters. So I've entered 6 characters, and now if I enter just simply 123, we now get a message that says password must be greater than 10 and less than 40. Also, as well as this, we can also identify common passwords. So if we grab a word list, we could potentially add it to a database and check over them names and say, this is a common password, you shouldn't be using this password. A lot of people use that to brute force password accounts, and people should choose another password. As well as that, you should also verify whether a person has the username and password as the same, and also if names or anything like combinations like 123 are involved. I mean, these are best practices, and again say that, you have the argument of usability and security, the biggest problems. Now with phishing, it's much harder to prevent, and it's all about education. You should always have periodic emails telling people about phishing scams. Phishing, you can't necessarily go through referrers because, they could be just entering the site directly and not be doing anything other than entering it in the URL bar. So you can't go through referrers because you'll get messages like this. Normally what happens with phishing pages is that they try to redirect to the other page, the page the person originally wanted to go on, or the company that they're signed up with, and they redirect to make it look more legitimate than just leaving them and exiting. So there's usually a redirect to the original site. If you want to have a look at phishing, you want to log your referrers to see what's having the most referrers, analyze them hosts, and see if there's any phishing going on there. And then you can decide to block or email that person, notify, and obviously this would be an automated system. So if we have a redirect, and this goes to land.php, if I just show land.php, what it does is it just gets all the headers and then writes it to data. If we look at data, we can see that it has a bunch of data, and I've also redacted the host. But basically, if we look, these two don't have anything. They don't have referrers whatsoever. But this one would. It has a referrer, and it has file manager, and it originates from index.php. And we can analyze this and see how many visits it gets per day, because they're not just going to look at taking one person. They're going to try and get as many people as possible. So you should attempt to have an automated system if you want to combat phishing, to analyze these referrers and see where your traffic is coming from. Analytics checks referrers as well. Although you can blank referrers, it's a defense that you could possibly have. Phishing is a very tricky subject because a lot of people do get caught out by it. The best possible way of just combating it is making sure that if, like other protections I've said, if someone's logged in a different area, location-wise, or they have a different user agent, or something's different than the norm that you normally would have with that user, it would be the IPs and user agents of the person, and that would identify them. And if it's out of the norm, then we should investigate that, maybe block that account and email them and say, hey, is this actually you? Are you from a different area? And that is the one way that I think you can sort of combat against phishing. So in this video, we've understood the need for password policy. Without password policy, we'd get common passwords, as do many sites on the internet, with 123, dog, or even just an empty password they might not have verified. And if you don't have a password policy, you won't get users having a secure site whatsoever. They'll just have attackers attacking them, and your company will look bad. So that's one thing that you've got to understand, is that password validation is very important when it comes down to registering users, as well as logging in, making sure that they haven't entered anything that isn't supposed to be entered. We've also developed some ideas on how to combat phishing with referrers, periodic emails, and checking their location and common user agents. And these are things that I think you should check, but it is hard to combat phishing to a degree. The next video we'll be looking at clickjacking. Hi guys, in the previous video we looked at weak passwords and phishing. With weak passwords, we saw that we could change and validate a password that's being registered to see if it has the correct length, and also ideas such as checking if it contains words that are available in word lists that are common, looking at 100 most common passwords or something like that, or common patterns, and these can help keep users secure. And we also had that talk about usability and security, how that you have to sometimes compromise your security in some form but also keep it secure at another. As well as that, we looked at how we could inform users about phishing and potential defenses. So in this video we're going to be looking at clickjacking. Clickjacking is a really interesting subject. So Specifically, we are going to be just looking into clickjacking itself. We're also going to be looking at clickjacking prevention and how we can change it. And we're also going to be looking into frame busting, which sort of goes into clickjacking prevention, but I want to talk about that in its own way. First of all, I'm going to show you a little activity of clickjacking so that you get a sort of solid idea of what we're talking about here. So I've got a little clickjacking demo here, and as you can see here, if we just click over here, my mouse has changed, so you may have noticed what might be going on. But as you can see, there's just some plain HTML here, free software download, and we got download here, a link available to us, and if we hover over it, you may not see this, but it goes to order.php. And if we look here, we've got a load of buttons, and if I just actually change some of the client-side code so you understand a little bit more what's going on, I'm going to change the opacity to 0.5. And what we can see here now is that the download button is right next to the buy button next to an iframe. And what's happened here as well is that if I just open up style again, we can see that the link is being put underneath by the z index with -1, and then we've also got the iframe which is being set to initially 0, but I've changed it for now to 0.5 to show, and we're also positioning it. I've just done this for the example, there's probably much better ways of doing it, but I've positioned the link right close to it so it looks like we're going to click the link, but then actually what we're going to do is we're going to click the buy button in the iframe. And this can help in, a lot of people would use the example of Facebook likes or Twitter followers, stuff like that. I think that is a fair sort of example, but you can also use it in other ways, such as if you're going to target an admin to do certain things, if you are aware of what is in the admin panel. There's a lot of things that you can do, and clickjacking can provide this. So now that we've put it back to 0, you can just see its download here. If we click here, what we're essentially doing is clicking buy, and it's in an iframe, so essentially we can't see what's going on. And if there was a one-click to buy option available on this website, we've just bought something because of this clickjacking. And there is something to defend against this sort of attack. So first one I'm going to show is a header check Google, and the reason I'll be doing this will come clear soon. So this redirects to a certain location, which we're going to choose here, and we're actually just printing out the headers. Oh, got used to Windows there. And what we're doing is we're just printing out the headers to see what's within it. So if we just go there, then we can see that we actually have something called X-frame options and same origin. And what this does is it basically says we only allow iframes or frames available within our origin. Now we've talked about the same origin policy before, and it is this: you have to be within the specific domain to have an iframe. So if we had an iframe with Google, it wouldn't be allowed because of this X-frame option that we have right here. So what I've done here is I've got the source google.com as the source on the iframe now, and I've also set it to an opacity of 0.5 so that we could possibly see it. I've refreshed the page and we can now see that there is nothing on this iframe. If we view the frame source, we can see a blank, and this is because it hasn't allowed it because we're not in the same origin. And this is a great defense that I think every single person, if they're using or developing a web application, they should be asking the web administrator, or if you own the web server, to have headers set as the X-frame options as same origin policy within your headers. Also, you don't want to put it into the meta tags in HTML. A lot of people have already highlighted this in various resources online, and basically this won't be read properly within the browser, so it's always best to put it as a header. So frame busting is basically to prevent iframes from happening within JavaScript. Kind of trivial and shouldn't be used, and basically what it's doing is it's checking its own location and the top location available and sees if they're different. If they are, then you're in an iframe. So I've just run the clickjacking demo, and as we can see here, the alert has come up because it's correct. I am in a frame. In localhost it may come up with some strange results because it's localhost, but it does work, the script essentially, but it does have weird functionality on localhost. Now this can be easily defeated with other JavaScript methods, and a lot of people don't advise it, and they also advise on just having the style removed after you've executed a script. Personally, I think you should just have headers and say same origin only, please. I don't want any iframes going through my site. In this video, we've understood what clickjacking is and the consequences. So you could potentially buy something, you could like a page, you could go into the admin page and get a button click. And we've also learnt about defenses such as the X-frame option in the headers, and the bad defenses, frame busting, where you're just doing it in JavaScript, which isn't a great idea and should never be used. In the next video, we're going to be wrapping up. Hi guys, in the previous video we looked at clickjacking and how that can affect a user, in which they click something that they didn't originally intend to do, but because of how it's done client side, they've clicked something and from a third party site. In this video I'm going to be wrapping up. So specifically we're going to have an overview of the course and what we've learned. I'm also going to give some advice on the end on what to do next, and I'm also going to do closing. So at the start we learned how to install Kali. First of all, we needed this, and I also gave a course overview on what we were going to learn. And then we went into the next section where we looked at SQL injection and XSS injection and the tools to use, SQLMap and XSSER, to utilize these vulnerabilities. And then we learned about filtering and validation and how we should use these on user input. And then we went on to the next section on local and remote file inclusion and learned about the distinction between them and directory traversal, and used the tool FIMAP. And then we went on to avoiding forced attacks, where we learned about hash brute forcing and how weak hash algorithms can affect users, and we used hashcat. And then we went on to form brute forcing and how that could affect a user as well, and we used the tool Hydra for that. And then we went on to learning about various different vulnerabilities in the section New Tools in the Arsenal, where we had an introduction to vulnerability scanners, which was WEAF, and then we looked at open redirects and open proxies and how these could be potentially used, and then we looked at remote command execution and how scary that could possibly be. And then we looked at information disclosure and what that could give to an attacker and how we can stop that so that they aren't able to fingerprint or be able to find information that may affect users and the server that you're running on. And then we finally went into this section with tampering data in packets, where we learned about how we could intercept and change data. And then we learned about Cross-Site Request Forgery, what it is, and the testing tools. We looked at my tool as well, and we also learned about CSRF tokens and same origin policy. And then we went on the final section where we learned about OWASP Zap, that vulnerability scanner, and some interesting features it had available to us, and also two-factor authentication and how important that could be potentially for users and administrators. And then we looked at clickjacking, the previous video, and how users can potentially be tricked into clicking something that they didn't really intend to do. And then we have this video, wrapping up. So I've got some advice that I think everyone should sort of follow. I don't think it's a religious following, just, some advice that I think I should give to you if you want to actively follow some web security further. I actively view, and I think everyone else should actively view, the Reddit r/netsec. It does have some web application security content on it nearly every single day, so you should check that out. It gets updated regularly by various contributors, and it can be really interesting to see what other people have on the opinion and what vulnerabilities they've discovered. So I always have this idea of you're never an expert. You should always try and better yourself, and I think every single person should always do that. Otherwise you'll be stuck, and you'll just, after a while, especially in technology, you'll start to have old, stale information. Also, I think you should actively follow web security blogs. Find them. I'm not going to say any, because if I say one, then there'll be another one that I should say. But you should search up on web security blogs and always look at updated information so that you don't have stale information. And with most things, I think you should always persist. Persist if you in something like web security, and a lot of the time rewards will be reaped and you'll be able to learn great things, you'll be able to do great things. So my best advice out of them 4 bullet points is to persist in what you love doing. Okay, so you guys can contact me if you have any reason to. You may be stuck, or you want to ask me a question, or you just want to talk to me at any time. My Twitter is @linkcabin, and if you want to see what I do, you can also check my website, which is available there. And finally, I want to say thank you to you guys basically for hanging in there, watching all the content I'm saying and putting up with my voice really. Because I guess it can get pretty boring listening to the same voice, but there you go. I'd also like to say thank you to Pack Publishing for this, allowing this to happen, and allowing you guys to learn these specific subjects. They do a real good job. Thank you for watching, guys.